Test. Test. Test 1, 2. '22. Long time not see a lot of people over there. Maybe some people are still joining. Not much. Okay. So welcome everyone, and we will start with some presentation today. Just before that, a few information. So today is in this place. Yesterday was another place. Tomorrow, who knows? Tonight will be some events. We will have more information later. Just in case, if you never come there, just follow the crowd, follow the crowd, follow the crowd. Very easy. A bunch of people know already where, welcome, Michael. And so we have few sponsors that may want to say a few words, maybe. Tony and Garrett, and some other sponsor will talk during the day. Again, thank you for all the sponsors for this conference. It's very, we are lucky to have you. And if you have few words to say.
Yep. Yeah, thank you, Mohammed. Our sponsorship is again threefold. One is the Leipziger Lerchen, Leipzig Larks, the marzipan pastry that some of you enjoyed yesterday already. And Jirka told me the Leipziger Lerchen are the primary reason to hold a physical conference at this time. So I think he's right. Secondly, we are sponsoring again student tickets, or this time only one, unfortunately. It's Hertha, she's over there, Hertha Albrecht, student at the University of Applied Sciences in Merseburg of information design, I think. And two other students couldn't make it. One has a mandatory class this weekend, and our two-time alumna, Hélène Quedipenda, unfortunately had a bereavement in her family. So our condolences from here, and hope she'll be with us next time. And thirdly, we did a substantial, I think, financial commitment to this conference. We are sponsoring also other conferences like Balisage, Markup UK, and Declarative Amsterdam, but XML Prague is by far the highest amount. Also because it's almost a home turf for us. So we are here now with 7 colleagues, and this is always a nice company event also for us to meet here. We can do so, we can afford to sponsor this because the last year was the most successful in our company history, despite working from home all the time. So I think Elon Musk is wrong when he says that people aren't so productive when working from home. Yeah, speaking of Markup UK and Balisage, the new schedule, 1 year XML Prague in late spring or early summer, and 1 year Markup UK collides a bit with Balisage, unfortunately. I mean, it's okay in Prague in late spring. The weather is fine, but there's some overlap between the weeks when you need to prepare the papers for Balisage and for XML Prague. And this is a bit unfortunate about that. But as Tony Graham told me yesterday, overlap is the biggest problem in markup. So enjoy the conference.
Thank you for the pre-publicity. So I'm Tony Graham from Antenna House. Ordinarily it would be Mike Miller here talking to you, but Mike had to stay closer to home for family reasons. Not COVID related, and he's fine and healthy. So it's me today. Antenna House is vendor of XSL-FO, CSS, formatter, and also of interest here, the regression testing system. If you want to talk to me about those, learn more about those, then talk to me during the conference, but otherwise, enjoy the conference. Thank you.
Thank you, Tony, and thank you, Garrett. So we will start right now with Ken presenting a paper on committee-based semantic model. And I see something I don't understand. It's XSD? What's XSD?
What is XSD? Morning, everyone. It's nice to see everyone. I'm bringing you greetings from Paul Cotton, who could not be here, and he was an attendee many years ago, and he likes being at this conference. He couldn't be here. A colleague of mine from Canada. And we're all thinking of Liam in his recovery. He couldn't be here as well, but he did present by recording yesterday, which was nice. So I bring you those greetings, and I am thankful to the organization committee for choosing to include me in the program today. I'm looking forward to bragging about UBL. Those of you who know me know that I like to brag about UBL and the things that we have done. And I want to thank the reviewers for their comments, and I hope that I have addressed all of the comments as part of my presentation. I have a lengthy paper backing up these few slides, so I don't have everything that's in the paper here. I'm just going to talk to the points of the paper that I will direct you to. They're in the proceedings, and I've reviewed the proceedings, and the paper is complete, so we're all set. My name is Ken Holman. For many years, I was the chairman of the UBL Technical Committee at OASIS and the chairman of the Codeless Committee at OASIS. I've stepped down from most of my standards obligations. I was a member of ISO in ISO's mirror committees in Canada for 31 years. And standards, I live in the ivory tower. Standards has been my life. And I love the way that standards can work. And I know that's not true for everyone. I hope to show you today how we were able to utilize standards in our approach to working with UBL that gave us the leverage to address 20 years after the start of UBL. We were able to address a community request for JSON schemas when we began with XSD. From day one, UBL has been XSD, and those are the normative standards, the normative expression of UBL. But we got a request from the community to support JSON as well, and we were able to do so very readily. Again, because I believe we followed the concepts of standards as published, and that gave us the flexibility and the power to be able to get to the point where I can push a button and out come both XSD and JSON expressions of the syntax available, two syntaxes then available for the content of electronic commerce documents. Now, I'm trying to say that very specifically, and I'll explain why in a moment. But first, let me introduce to you the world of the Universal Business Language. This is a set of e-commerce standards, electronic commerce standards, widely deployed around the world now in many four-corner model networks, adopted across Europe as part of the PEPAL project, which has now expanded to Singapore, Australia, New Zealand, Japan. In the US, the Federal Reserve Bank of Minneapolis has been facilitating the BPC network, and the hub format across this four-corner model network is UBL XML, and it is used in South America. It's being looked at from Africa. It is a global standard for the semantics, for the syntax expression of the semantics of electronic commerce. And if you think about procurement, in the diagram here, I show the use of UBL in the circle of procurement, starting with tendering to quotations. You make an order and you ship some material. Well, that jumps into the area of transportation, where you have to schedule the transport, have waybills, get your transportation status, maybe a freight invoice, and it gets received, which triggers an invoice. Now, we mesh well with ISO 20022, a banking standard, so that you can then, using 20022, work with banks to get your payment out, and then the remittance advice is the evidence of the payment, and then you check your product activity and the availability of your stock, which might trigger more tendering and more ordering. So it's a circle. procurement, and then this bit about transportation. So UBL addresses procurement, transportation. It does not address the banking because we don't want to step on anyone's toes. So, Open EDI standards. 30 years ago, in the early 90s, ISO IEC 14662, the Open EDI reference model, was developed. And this recognized the separation of the business-oriented view of electronic commerce and the functional services view of electronic commerce. So the business view is the world in which I do business, who I am doing business with, the rules of business, and the bundles of information that are being exchanged in business. And ISO IEC 15944 Part 20, you have to get used to all of that when you're working with standards, illustrates this separation and how the many components of the semantics, you have the environment in which you do business, the scenarios between business trading partners, the roles of the parties involved in those scenarios, and the bundles of information that are exchanged. And notice the use of the word bundle. There is no implication here of syntax. This is a semantic expression of the kind of information that needs to be exchanged. Now, in the functional services view, that's where the rubber hits the road. This is where you need user data. You need syntax. You need the ability to express those semantics in a way that your trading partner is going to be able to consume, ingest, and do and respond to that information in the business context based on what it finds in the user data, which is choreographed and sent along some transport mechanism between parties in order to get it exchanged. So, the scope of UBL is only two areas according to 15944 Part 20. What goes into an information bundle and what that information bundle looks like in syntax. And if you, the right-hand column, ISO IEC 19845, that's the UBL specification from Oasis as an ISO standard. Section 2 is what can go into an information bundle, the semantics, the abstraction of what goes into an exchange between the roles of trading partners in a scenario in a business environment. Well, the user data associated with that are the schemas, the document constraints, the use of digital signatures. Those are the other sections of the standard. So we have even written the standard document recognizing the separation of the semantics of the information being exchanged and the syntax for that. Well, we are all practitioners of XML, and we like to use all of the many data types available to us in creating elements with arbitrary attributes and the kinds of things, and we have often looked at our information directly at the XML. What can we do with our XML to express this information? And we have a plethora of data types to use. There's a more limited set in JSON, but sure enough, you can take your information, you have to express it that way. And that is not the way that UBL has looked at data. Again, because it is looking at the semantics of information bundles. Again, no implication of syntax. What is in the information bundle? And there is a specification from the United Nations Center for Trade Facilitation, UNCFACT, called the CCTS, Core Component Type Specifications, and, Core Component Technical Specification, which includes the definition of these core component types. This is as low as you get in an information bundle expression. There is no implication in this left-hand column of core component types of anything to do with syntax. What is an amount? An amount is a number plus a mandatory currency. That's what makes it an amount, is the mandatory currency. That's called that's one of the supplementary components. And so on the right-hand column, you have supplementary components. And some of them are optional, some of them are mandatory. Some of them are constrained to XSD date and time in our use of CCTS. And that's a bit of a trade-off there in the formal specification of CCTS. It can be any string at all for date and time, or any string at all for indicators or true-false values, but we've made the trade-off that let's constrain ourselves to ISO 8601 and the true-false values in XSD. But notice this left-hand column. These are the kinds of semantic business-based objects that the business people in the committee understand. There are very few angle bracket people in the UBL committee. Most of the UBL committee is all about the business of UBL, what gets expressed in the information. And these are the only types available to them. They have done all of their expression with this left-hand column. They don't know elements. They don't know attributes. These business experts are focused just on these core component types. Well, in this diagram, you see the core component types at the bottom. They are used to define unqualified data types, which might get qualified for things like code lists. These get used as the leaves of a hierarchy, leaves of the tree of business information, which get used in the branches of the tree, which are the ASBIEs. And these are defined by their shape, and their shape is specified in an ABIE, an aggregate. And at the top left, you can see the document ABIE. Well, put this into a UBL context. On the left, you have the UBL library as published by the UBL committee. 91 different business documents are defined in 2.3. There will probably be over 100 in UBL 2.4. This is a very large library. We are not expecting users to use the entire library. There are 4,000 elements, or 4,000 business objects in the core library. These 91 onion skins define the document element. Then all of the branches are defined by the common library. So all 91 documents share the definition of an address. They share the definition of a price. They share the definition of an exchange rate. All of those are shared across the library. So whether you're doing procurement or transportation, this is the attraction of UBL in the community right now, because you implement the business objects by the syntax, and you know you're going to get the same syntax for every business object because it's a common library for the 91 different document types. Now, on the right-hand side, a particular user community will use a subset of UBL. They will choose to use a handful of documents. They will choose to add their own documents, and because of the core library, they can add their own document elements, they can have their own private libraries, they can all be mixed. Very few people do that, they stick to the UBL, but it's all there in the architecture. So the way the UBL committee, the way the UBL committee defines these ABIEs, these structures, these shapes of the branches of the tree, is in a spreadsheet. These are business guys. They know how spreadsheets work. They're comfortable working with spreadsheets. There I have, and I'm not expecting you to read this, but I'm showing the definition of an address as being, looks like 24 leaves of the tree and 3 branches which have other information below it. And column C shows the cardinality of these constructs as defined by the committee. And a user community cherry picks what they want in their definition of an address, and then the community chooses to use this. But for the committee, we define those common semantics that we expect people to understand, general accounting principles, general information concepts that are agreed by the committee and commented on by the communities to tell us, yes, you've got a good understanding of these business semantics. So back to the diagram of 14662, the BOV FSV. On the right-hand side, you can see that there is a transformation from the business objects to the validation artifacts. And these are called naming and design rules, NDRs. And the way a standardization committee implements the NDRs dictates how the syntax is going to be reflecting the business objects. And there is not consensus in the world about NDRs. The NDRs used by UNCFACT are different than the NDRs used by UBL. An important example is that in the UNCFACT use of coded domains, code lists, values, they bake in to their XSDs enumerations of the coded values. The UBL committee says no. That is data. That is community-defined content. And the UBL committee does not want to step on or dictate how a community is going to be using the UBL definition. We only want to define structure. We do not want to define content. We want the community to define content. So we have split up validation into 2 significant steps. The structural and lexical validation that can be accomplished with XSD, telling us that the information is in the correct place, the information has all of the required components, and the data inside those elements and attributes is correctly formatted, and that's all the committee says. The committee then expects the community to have a second pass, and we've illustrated it with XSLT. It doesn't have to be XSLT. We use, many of our communities use Schematron to express the value constraints, and that is what is used to confirm that the content is complete. We do not bake in any assumptions of user data into our XSDs. Another significant difference in the schemas is to expect the unexpected. And we know in our committee that we have not thought of everything. We know that there will be user groups out there wanting to use UBL who have requirements that we haven't thought of. And so we have baked into the UBL schemas an extension possibility at each and every branch of the tree, so that our communities can extend any one of the business objects to include their additional information expressed the way, however they want to express it. Perhaps there's another committee, a W3C committee or something that has a standard for expressing content that we have not included in our committee specification. They can include that at any branch, and they take their extended information record, They put the standard bits into the standard UBL, and they put the custom bits into the extension. The actual way that artifacts are generated has been automated. I am trying to step away from the committee. I am trying to spend more time with my grandchildren. I am equipping the committee to be able to create all of the validation artifacts on the push of a button. It is all automated in GitHub. That spreadsheet that I showed you the picture of before is on Google. Whenever any user checks in and pushes a change to the repository, sometimes it's just touching a file in order to trigger the change because there's no change to the actual GitHub contents, but every push will go out and fetch the spreadsheet contents, transform it into generic code, produce all of the reports, produce the supporting documentation, produce both ODF and XLS versions of the spreadsheet, because there are users out there who still want to look at the data as spreadsheets, and produce the XSDs and the JSON. And this was all that I had to change to get JSON. Is all we did was look at the naming and design rules and incorporate the serialization of business objects using JSON schema, and we're using draft 07 for now, so that users of JSON can have the expression. And we were able to do that because we looked at our information semantically. We did not jump in with both feet and start doing XSD and XML syntax from day one. From day one, we stuck with the semantic expression of the business objects. That meant that in the artifact production, I just had to write some XSLT to create JSON schemas of the same business objects as the XSD. And that is a separate publication than UBL. It's the OASIS Business Document Naming and Design Rules. And all of the references are in the paper that's part of the proceedings. Well, one of the questions from the reviewer is, why are the schemas so complex? And, well, they're intricate. I don't know if that's a softer word than complex, but because at every level you might have naming conventions that will collide. And so we wanted to put each of the layers of the schemas in a different namespace so that each layer could use the same names where applicable. But in this schema hierarchy, I bring your focus on the right-hand set of arrows down at the bottom, the CCTS-CCT schema. This schema fragment defines the core component types, and in the UBL hierarchy, it is the UNCFACT publication. It is their XSD file that we are using at the base of our entire schema tree. And that promotes interoperability between other users of CCTS, because we're all using the same base schema, and we build everything on top of that. So finally, putting everything into context, I bring you back to the diagram of the OpenEDI reference model on the left. At the top, we have the business-oriented view, which is the semantic perspective of what it means to do business and what kind of information is exchanged between trading partners. The bottom half is the functional service view, where the rubber hits the road, how the actual machines are going to communicate this information successfully so that the abstractions can do their business because they have successfully exchanged the information. The second column separates it up. The environment in which I'm doing business, the scenarios between trading partners, the roles of the trading partners that are going to exchange information bundles. Those bundles are expressed as user data in a choreography across a transport network, and I've shown you UBL filling in the bubbles for information bundles and user data. But what about the other bundles? Well, in Europe, PEPAL has adopted the European norm CEN-BII, the business interoperability specification of profiles for scenarios and roles, and a syntax binding to UBL, and PEPAL provides the legal framework. So you can see that UBL doesn't try to address the business semantics, it's only trying to address the information semantics. And that, in one picture, shows everything. It shows the business document, naming and design rules, transforming the business objects into the schemas for user data, but it's all in a context, and every user community of UBL should be having this context of the scenarios and roles and the legal framework and the business environment in which this is all used. So what are the implications for your own data? Can you find an abstraction for your information? Do you have to jump into the XML? Do you have to? Can you think of an abstraction that expresses your information? Can you mechanically produce the rules? Imagine if they asked me to hand author 4,000 elements in the UBL schema. I would not long have been a member of the group. So, model your document using this abstraction that you define, and then generate the validation artifacts. And once you're generating the validation artifacts, you then have the power to generate different sets of validation artifacts. And something I want you to take away from this is don't forget to expect the unexpected, because I doubt that you've thought of everything. Your users will think of things that you haven't thought of. So please try to accommodate your users. So try to think in your own, walk away from this presentation looking at your own data, thinking of how the UBL committee has used a semantic perspective to insulate itself from the syntax, which gave us the power 20 years after we started to push a button and produce JSON schemas for those who want to use JSON to interoperate instead of XML. Thank you very much. I'd love to answer any questions. I went 2 minutes over, so there's a bit of a shorter time for questions. But I tried to convey everything. Yes, I have a question over here. Yep.
Wait a minute.
Yep, do the Donahue thing.
Hi, Ken. This is Michael from yesterday.
Yes, hi.
Thanks for showing a working standardization process. As yesterday we talked about several efforts that kind of went stale. So
Oh, okay.
I have a more technical question. You mentioned you written some XSLT to create the JSON schemas.
Yes,
Did you use the XML to JSON function of XPath?
I did not.
You did not. So you went through all these
Text mode. Text mode, and I kept track of the brace brackets.
Okay, my pity. Because otherwise, I guess we would be kind of quite close to having a linearized XSD, XML, transforming that into the JSON XML representation, and then...
Well, to make my job easy in doing that, I did go through an intermediate hierarchy of JSON concepts as XML elements or nodes in a tree.
Okay.
And then I had a brainless serialization of those nodes with brace brackets.
Okay.
So I did have, I didn't try to jump right to the brace brackets as an interpretation of JSON schema.
Okay.
I went to a node tree of JSON schema semantics and then just serialized the node tree.
You've written your own XML to JSON function, basically.
Yeah, yes, I refrain from using that phrase because XML to JSON gets abused, in my opinion, because there are too many different ways people want to see the JSON of an XML.
I see. Thank you.
Yes, O'Neill.
Hi, you showed a slide where you had a two-phase validation
Yes.
schema to, and then an XSLT. The application code, what does that mean? Is that just...
Oh, that's just implementing the business semantics for the data. And that's outside the scope. One of the questions from the reviewer is, what does UBL do about business semantics? And business semantics are up to the user community, and we're not trying to tell users how to use UBL. We're only telling them what's available in UBL to be used. And so the application code is that user community's reaction to ingesting a business document.
Right, thank you.
Yeah, UBL does not try to tell users how to do business. Just a quick one, there's another question over here.
Just an add-on. Could this step has been handled by Schematron, or is it?
It is by Schematron.
Okay.
Yeah, we do define the XSLT by Schematron. That's my presentation tomorrow at the Schematron user community.
So Ken,
Alan.
So Ken, it's very impressive. Do you see it? Oh, sorry. Do you see it as being important that the JSON schema is still the standard is still in draft? Is that been a drawback?
I have no opinion on the fact that it's draft. Draft 07 has lasted a long time. If the user community comes back to me and tells me that I made the wrong decision in choosing draft 07, I'll make a change. I confess I don't have a lot of enthusiasm for JSON. And you can if you look at my LinkedIn essays, I responded to an XML dev question about XML versus JSON. And I say it's different horses for different courses. And I will let the user community tell me what they want. Or tell my colleagues what they want, because I want off the committee. Thank you for your attention this morning. Enjoy the rest of the conference.
So next presentation, maybe, oh, is it there?
The X definition in the new version 4.2 for processing and converting of XML to JSON to XML, XML to YAML to XML. And we will present shortly the special form of recording of data, which we call XON, X definition object notation. I will start with something what some of you know, but I suppose that most of people, or not all people, do know what X definition is. So X definition is a programming language that was originally designed for processing of XML data. And it is open source now, available at this address. Each X definition is written as an XML document. So it is a language which is written to the XML form. One X definition can describe the structure of one or more models of data objects. And it is possible also to declare some methods, types, and variables. X definition may contain a reference to another X definition, so you can have the set of X definition interlinked together. And collection of X definitions is compiled to a Java class. It's a compiler. The X definition starting with version 4.1 describes data models for JSON, YAML, properties, Winin, and CSS. Now it's 4.2, sorry. Anyway, I must say something to this. X definition 4.2 is not yet released, and X definition, the last build of X definition 4.1 supports all features which will be described here. So, X definition 4.2 will be released in next few days, weeks, months, years, I don't know. Now, to understand a little bit what we will speak about, it's necessary to recollect or to remind what is XML and what is JSON. XML data model in Java, for instance, is represented by document in the W3C document. And it's important to know that all values of attributes and text nodes, practically all values in XML, are just strings. So the actual work with any XML data requires knowledge of properties of values that are described in, for instance, in XML scheme or relaxng or in X definition. JSON data model is possible, is represented as Java map or Java lists. It means this way it are implemented instances of arrays or of maps or objects, how they call it in JSON. And the data, we call them primitive data, can be not only strings, but also numbers, Boolean values, or null. Properties of JSON data object can be described externally in JSON data or in X definition. To realize the project of X definitions and JSON data, XML data, and some other formats of data, it requires the unambiguous transformation of both forms, of all those forms together, vice versa. It means XML to JSON and JSON to XML. And it must be unambiguous. And we can then define some kind of format which we can use internally for all those formats. So JSON map, the XML can be considered as JSON map with one named value. It is the name of attribute. It is a tag tag name of attribute of element, and then follows the this value is a JSON array, and the first item of this array is again JSON map, which describes the attributes of the element, and it can be, of course, missing if no attributes are present. And the following items in this array can be again elements transformed with this algorithm, or it means JSON maps, or JSON text values. So here we have simple example. Let's have XML describing some book which has title, date, and as you see, it can be more authors than one. So the JSON form will be book. Then the array, it is the named value of array, and there are attributes, title and the date. It is this first item of the array, and follows the elements which are child elements of this element, author, those both authors. How to describe it in X definition? Those people who know already X definition knows. I just remind that in X definition we are describing the types and the occurrence of items by the special form of attribute. We call this language X script, and we can say occurrence. We can define occurrence of element, and this element has again the string. It is the X definition describing the element of book. And what we shall do with if it's data. So we need to put it into the special element which we call XD-XON. We must say the name of the element because in JSON it can be map or array and so on. We don't know. We cannot simply know the name of to which we will refer from other X definitions, or to say what is the root definition. So the name will be book. We make it with oh, it's again the error. It should be the root. It should be small letter, not big letter. And in this element, we simply put the JSON. And in this JSON, all values, we replace the same way like we did in XML. Anyway, we need something special. So it is X colon script equal sign instead of, it's not JSON, it's the special JSON which is used for description of JSON. So if we need to put something special, we make it with this recording X colon, and here is the keyword, and it is equal sign. So this way we can put into the JSON, description of JSON, some commands for X definitions. So principally it is very simple. All the values we can describe. We can describe typos. This is string, this is some year, months, form, and so on. And we usually put the occurrence. To values we can say occurrence directly here, because value can be or cannot be. It's just required or optional. And for the for other objects we can put it here. It's connected to the array. This array can be here in this map in this array can be here occur unlimited times. Now, what to do with JSON to XML? Here is Michael Kay, who described it a few years ago. It's very precise and very good algorithm, but it's not so useful for our purposes. It's not so readable and so on. So we used a little bit different algorithm, being inspired with Michael Kay's ideas. And it is much more complicated. JSON cannot be easily converted to XML. XML can be easily and precisely converted to JSON, but this is not so easy. Because JSON has maps, arrays, and primitive values. As the map can be empty, there is something new. What is the empty in XML? The array can be empty. What it is, empty array? The map can have more items. So if it's map which has more names than one, if it's one, we can it transfer still to element. But if it's more, so we will need some special. Yeah, so I will be very, very fast. So I will show it. I'm slow. Yeah, you can see here the example where we need to put the special element if we want to transform it to XML. This is element with the namespace from XDefinitions, and this map is describing this map because it has two names, so we cannot simply create an element from that. So we must say it's map, and to the values we record the value of named values to the special attribute value if it's simple value. Moment. I have here somewhere an example, and it will be the last thing which. This is example how to how it, for instance, this example will be transformed to. Tomáši, prosím. Jo, dobrý. Have we here? Is it connected to? No, it's not. Tady. Forget it. No. Now let's say something about XON. The XON is a data model which is extending the JSON. It's exactly like JSON, but numbers can be described in detail. Number can be integer, can be byte, short, long, double, float, and so on. Or it can be also the date times, durations, and many other types of values. So XON is describing all data types which are supported by XML. So let's have this JSON example. Here is And here is written a comment what we will expect it is. In JSON, it is just string. It is minus infinity, negative infinity, true. Now it is duration. Here it is a byte array, and so on. So this JSON we can transform to XON very simply. That in JSON we have comments, so we can write comments here, and with the red letters is specified what kind of value it is. If, for instance, there is not written S, then it is a number. It is an integer. If here is not this small f, it will be double, and so on. This in JSON must be string. Yeah? If you look back, now, similar way we are processing also Windows ini files, properties, comma-separated values. All these structures can be described by XDefinition, and we can use XDefinition as a general processor which is able any XML, any JSON, any create to XON, and from that we can create back XML, any of these formats. Or we can use directly XON to communicate with some other system. I'm very sorry, I am very slow and very old, so I will give floor to my friends for a while.
Hello, everybody. Is it working? Nope. Low battery.
Switch it off.
So we switch the microphone. It's a little faster.
Take.
Hello, everybody. I would like to thank the architect that he describes very briefly the XON. My name is Tomáš Schmid, and I will show you a few and very fast practical examples of using XON. And the first example is how we can process the data from JSON and the XON. This example is about that we have two types of different input data. Meanwhile, we have only one description of the data model. It means we have one validation model. On this slide, here is JSON. So I think it's well known. It's composed from two records. Those records are structurally equals. We can see that each of the records has 4 elements, and on the first line there is an array of those records. So this one is the JSON. Similarly, we can create same data in XON. There is very small differences, and especially as Vašek mentioned, it's in the type. Everything else is the same. So if we want to validate or somewhere else process those data, we can use, for example, this XDefinition. This XDefinition is quite different. We have presented here at XML Prague many years ago for the XML purposes. This one is for XON, but we can see that we can process the JSON data and also the XON. The structure is really very similar to input data, so we can think that it's easily to read and use. based on this very simple example, we can build our, let's say, more difficult real case scenario. We already know that we can use XDefinition XON to validate JSON. If we combine this new feature with stream data processing, which is already implemented in XDefinition, we will be also able to process huge or very large JSON data, which you can receive from your customer or whatever else in the repos, for example. So, the real case scenario is telecommunication. Imagine your company has a task that you have to process data containing information about devices in the network. Those data in JSON format, which is typical standard today, and you are receiving those reports for some period. Let's say it can be 1 day, 1 week, and it means it will contain thousands or even millions of records. So my question is, how would you like to process those data without loading whole file into your memory? And you don't want to spend like 10 of gigabytes of memory for processing these files. And the next question is, how you want to do that if you want to spend so much memory without your own data parser? Well, one of the possible answer is you can use the XDefinition. This is very simple example from one of the possible customer. We can see there is very simple record with few elements. In the real case, it's really huge or bigger. And this is only one of the record in the whole payload. We can imagine that there will be really millions. So we can use this XDefinition, which continues on the next slide, to describe the record. There is a continue, and also again we can see that it's very similar to input data. If we use this XDefinition with the rest of XDefinition technology stack, we can process the data by the streaming way, and it's free. So that's for the real case user scenario, how we can use XDefinition for cases if we need to process the JSON instead of XML data. The future development is like we are finding the ideas what we can do else now, because we already start to process a lot of type of input data. So the question is what else? What's next? As now we are focusing on accessibility. We want to open XDefinition to the world that other people can use it for free. As far as we know, the main interesting about this technology is especially the streaming data processing. People are coming and saying, hey, we have a problem with processing a huge data file, for example, 20, 30 gigabytes and more even. So that's the main reason why they are trying to use XDefinition. We open sourced this in 2018. Now we have a few other people who like that. And the next our step should be focus on platform independence. XDefinition has been for a long time developing as internal tool, and it's very hard linked to our platform, which is the Java. And this is quite a weakness of the system. So we would like to create a general standard which would be independent on the platform. It means that we should create the new, let's say, derived specification on the current specification of XDefinition, and this standard can be implemented in any platform. It can be one of our goals. The standard will be very similar to currently one, so we need to reuse the basic blocks of the X definition. So it means we need to data types, which can be, for example, extended by any programmer if you need for your internal uses, for example, internal data integration. Then you have a structure, so you need to somebody describe how the that input data can look like and what's the type of them. Then we use the events. So that's of course we have something like internal data processing in the X definition, and the events are internally triggered, like the life cycle. And the last part is external methods. If you want to call your own code to some other logic to validation or any other operations, it just depends on you. And it should be everything for me because we don't have so much more time. And thank you so much for your attention.
We have 1 or 2 minutes for question. Any question? Oh, thank you again. Thank you very much for the presentation. Next speaker will talk to us about
Sorry, just plug in my presenter. Okay. All right, abstractions. So numbers are abstractions. You can't just point to the number 3. You can only point to 3 somethings, like 3 bicycles, or 3 sheep, or 3 examples on a screen. You can represent 3 in a number of different ways, and this was just a result of me searching for 3 in the Unicode standard, and it's only a selection of them. And you can concretize numbers in a number of different ways. For instance, a length, a weight, or a speed, or a temperature. But in the end, these are all the same versions. These are all the same 3s. There is only one 3, but it's in our heads rather than in the world. Now, data is an abstraction as well. It doesn't really matter how you represent it in the computer. You've got one abstraction, for instance, 20 degrees Celsius, and then you can represent that in different ways in different representation languages. But in the end, those representations all represent the same abstraction. And it's worth noting that HTTP recognizes this too, because a URL represents a single resource, a single abstraction, and then uses content negotiation to select a particular representation of that resource. So IXML at its base is all about that. It takes a representation of data, typically with implicit structure. it uses a description of the format of that data in order to recognize the data structure. It creates, as a result, a representation first internally with explicit structure of the data, and then you can do anything you want with that structure. For instance, you can serialize it as XML. Some representations in the world are weaker than others. They may not be able to faithfully represent all the abstraction, and therefore they're not reversible. XML is probably the best available representation we have, generic notation for generating representations, I should say. So the intention behind IXML, Invisible XML, is to allow extracting abstractions from representations, converting weaker representations into stronger ones, in other words, explicitly structured ones, and therefore XML is an excellent target for those representations. So this is the processing step, the basic processing step for IXML. What you've got is a textual document with a description of that format. The processor then takes those two things and generates a structured version of the document. So the square things are textual documents. Triangular things are some structured representation of data. So in these two things are the same abstraction, as it were, just in two different representations. Now you'll notice the description there is in a triangle, in other words, in a structured version. But normally, you supply that description in IXML, which is a textual document describing the format of the document. So in fact, there's another step involved. Here you have the description, and it takes the format of IXML. It converts it then into the same description, but then structured, which is then used for converting the document into its structured version. So this is the whole process, and of course, to get that initial structured version of the IXML language, you have to go through a bootstrap phase in the first place. So, in fact, these two together is the normal operation of IXML. It takes the description, structures it, as it were, it takes the document and uses that structured description to turn it into a structured document. So I'm going to very briefly talk about how IXML looks and how you define the format of a language. So for instance, and I'm going to use here a programming language. Let's just assume we're trying to define a simple programming language. So it consists of a number of rules, and a rule consists of a name and then a number of alternatives for that thing separated by semicolons. Alternatives are just a sequence of items, 0 or more terminals and non-terminals separated by commas. So for instance, an assignment is an identifier followed by colon equals, literally, followed by an expression, whatever an expression is. And then what happens is that input is taken, and any input that matches that grammar is parsed into a parse tree, which is then serialized as XML. So if you've got some definition of your language, and you've got input I becomes 0, then you would get output that says, this is a statement, it's an assignment, it contains an identifier I, colon equals an expression, which is a number 0. By default, and this is important for later in the talk, all input characters end up in the output. So all that we've done is inserted elements, or tags rather, around the input to show you what the structure of the input is. Now you can control your serialization by adding marks to the IXML definition. So for instance, if I put an @ sign before the ID, I'd be saying that I want that thing to be serialized as an attribute on the element. So then I would get assign ID equals I, and then the rest just the same as the first time round, the expression. You can also mark things to be deleted from the output. So for instance, if I put a minus before the colon equals, then it just doesn't turn up in the output. And similarly, you can do that for non-terminals, for instance, expression. If I put a minus before that, then the tags for the expression don't appear in the output, but you still get its element content. If you know IXML already, you'll be, here's something that's new in the new version, that you can actually also add things to the output that aren't in the input. So this isn't a particularly useful example, but for instance here, this adds a semicolon into the output, into the text of the output. There are more useful use cases, but this is just to show it working. Now there's much more, and you have two options. You can either go and read the specification. The slides are online. You should be able to find them easily enough. Or otherwise, you can go to the tutorial, which is also online. Or tomorrow, I'm giving a tutorial, and you can just come to it. But you've seen the essence, and that's all you need for the time being for this talk. So here's just an example in use, actually, for this conference. The one thing that I really loathe about producing a docbook for the conference is the damned bibliography, which I struggle to get right. And so I just wrote an IXML grammar for the bibliography for this conference. And so, for instance, I now have a textual line that has the abbreviation spec, author's name, who's an editor, the title, the publisher, the year, and a URL. And so the IXML grammar, which I use to process this, says a bibliography is one or more biblio-entry values. A biblio-entry consists of an abbreviation and either an author or an editor, a comma which gets deleted, a title, a comma that gets deleted, a publisher, a comma that gets deleted, a publication date, a comma that gets deleted, and then optional page numbers, and then 0 or more biblio-miscs, which are URLs, or biblio-IDs, which are ISBNs and DOIs, and so on. And so running that through this, I get my biblio entry for the conference, which made my life very, very much easier. So anyway, I'm here to talk something about the implementation. So the IXML is actually a grammar. And so you use a parsing algorithm to take that grammar and the input and turn it into the output. Now, there are many known, very, very many known parsing algorithms, and most of them have restrictions on the languages that you can define or process. Now, we didn't want those restrictions, so IXML requires implementations to use a general parsing algorithm, of which there are a handful, that doesn't add any extra restrictions. So the pilot implementation that I wrote uses early, which was one of the earliest and best known of the general parsing algorithms. And as I've described in an earlier paper, you can see it as a pseudo-parallel parsing algorithm. What happens is that when you're parsing a rule like sentence is A or B or C, it splits into 3 parallel subparsers, all starting at the same point in the input, one for each of those alternatives. And if a subparse fails, it just terminates and doesn't do anything. But if it succeeds, it records its subparse trees and terminates. So at the end of the parsing, what remains is a sort of parse forest of lots of these little subparse trees. And so the first thing you have to do is to see whether the parse was successful by looking to see if the root node of the grammar has a parse that covers all of the input. And if it does, then you can go on to serialization. Serialization just does a tree walk over those parse trees. Non-deleted terminals then just get serialized to XML elements. Deleted non-terminals just have their children serialized, so it doesn't produce any element tags. And non-deleted terminals and insertions are just output into the serialization. There's a bit of extra work for attributes because they become before the element content. And so for non-deleted terminals, you have to do one subwalk, and it's only a very short one actually, for the attributes, and then one for the main content of the element, which is down the whole tree. There's one quirk. Because of element deletions, here this example, for instance, a sign is a target, and a target is an attribute ID. Target has been deleted, so there's no element to put the attribute on. So it has to actually be walked up one level and end up on a sign. So that complicates very slightly the tree walk for elements, because you have to go down deeper through deleted elements to see if there are attributes that have to be on the higher level element. The parse may have been ambiguous. The classic example, time flies like an arrow, fruit flies like a banana. So the same string can be regarded in two different ways or more. The serialization tree that walk doesn't matter. It just finds one parse and then just serializes that. But of course, you as user of the output, it's important to know that this was only one possible structuring of the data that you got. And so IXML requires, on the top level element of the serialization, IXML state is ambiguous, just so that looking at the output, you know that there were other possible interpretations. This, to get this, it's a very simple extra tree walk just to see if there's any root from the top node that's ambiguous. So the pilot implementation I wrote actually to support the development of the language, because it's been changing over the period of development as it's been tested on users and generally be made better. So it was there to try out different approaches and find different solutions to the problems. And of course, to generate example outputs for the papers that I wrote about it. So my primary aim in writing it was speed of implementation, flexibility so that I could change it quickly. And I wasn't interested in creating an industrial strength top speed implementation. That could come later. So it's actually written in an interpreted language with very high-level data types, ABC, which was the predecessor of Python. It's about 500 lines of code for the bootstrap parser and 700 for the full processor. So now to talk about future work of the implementation. So in this diagram, you can see the description gets turned into a structured output, and the suggestion was that that's always XML. But in fact, the parser just needs the structure that it needs to describe a grammar. So one thing you can do is actually serialize straight into memory rather than into XML, serialize it directly into the form necessary for the parser, so into the internal form. So this allows for some simplifications, because an IXML parse will never be ambiguous, so you don't have to do certain sub-steps of the serialization. And of course, it speeds it up since it eliminates one whole parsing phase. So that's some future work. Another thing that I want to investigate is the possibility of round tripping. That is, you've got your input format, you've produced a structured representation of that, but it will be interesting to see to what extent can you get the original form back, having done that parse. Now, in the very simple case, where you haven't got any deletions or attributes or anything, then it's just trivial, because all you have to do is concatenate the element contents, and you've got the original form back. And even with element deletions, there's still no problem there, because you haven't deleted any characters, you've only deleted elements. So it's still simple. The problem comes if there are terminal deletions, where you've deleted characters from the input that haven't turned up in the output. How do you get those back? And in the general case, the only way to deal with this is to parse the output back using the same grammar. And I'm going to show you what that involves, and it's actually quite an interesting problem. So what you need is actually a parser. It's very similar to early. You can just use an early parser, but with a different way of handling its input, in order to discover which characters have been deleted so that you can put them back in. So you're parsing the parse tree, in other words. So for instance, if you've got something that's been parsed as a statement, then to parse this parse tree, to go back, then you're going to expect the tag statement to start off with. Then you split off 4 subparsers in exactly the same way to do the other bits, which may fail or succeed. And then at the end, you have to expect the slash statement, the closing tag at the end. If it's a deleted terminal, if there were a minus before that statement, then you don't expect the statement, but you still initiate the 4 parallel subparsers. To parse a non-deleted terminal, you have to just expect that very same string in the element content at the current point. Easy. To parse a deleted terminal, you match 0 characters and then insert the string in the parse as if it had been there. To parse an insertion, you expect the characters in the string, but add nothing in the parse. All right. So those are all fairly simple cases. Attributes cause a problem because the content is out of order, because the attribute content appears before the element content. So what you have to do is hold the attributes in abeyance as separate input streams, and then when you come to the @ sign in the grammar, that's when you switch to the input to the content of the attribute with that name. And then you treat all subrules from there as if they've been deleted. So the parsing result of this is for a serialization like assign with an attribute ID and then an expression where the expression element has been deleted and there's been an insertion of a semicolon at the end, you will get a parse tree at the end of this just like that. In fact, just like the first version with no deletions and no insertions. And then you can just concatenate the element content to give I becomes 0, exactly as in the very simple case earlier on. However, there is a problem that you could get ambiguous parses of the parse tree. And an example is if you had an expression language that allowed you to use different brackets as long as they were matched. For instance, squiggly brackets or round brackets. The problem with this, since the terminals, the brackets have been deleted in the output, is that they will both produce the same parse tree, a term with an expression in it, but you don't know which of those 2 alternatives produced it. Parsing that serialization back will give you 2 parses, one with the squiggly brackets inserted and one with the round brackets inserted. So you've got an ambiguous parse. And so just as with serialization, we have to choose one of them. And so in other words, because the serialization deletes information about which brackets in this case were used, we can't always round trip perfectly. We can just get a version of round tripping. Similarly, if you, in the programming language, you deleted all spaces and comments, that's not in the output, so you can't regenerate the original spacing. You can't regenerate the fact that there were comments anywhere. They're just lost in the round tripping. So designing a notation requires a lot to be taken into account simultaneously: usability, functionality, ambiguity. Having an implementation that's easily modifiable during design of the notation is almost essential for good progress. The current pilot implementation, which I'll be using tomorrow in the tutorial, has served well. It works well, but now other implementations are emerging, and so I will be retaining it for future design research. That's not quite the end, because I've got an announcement to make. This moment is the formal announcement of the release of version 1.0 of IXML. Now, I'm hoping that Norm Walsh is online. He said he'd be watching. He's now going to press the button to release the information that has been released on invisiblexml.org. If you go there, you'll be able to see the final specification, introductory material, pointers to the tutorial, several implementations. We have 3 or 4 implementations that you can use, one in Java, one in Saxon.js, my one, which is a web service, and we have several example grammars for you to have a look for well-known content. And please do come to the tutorial tomorrow. Thank you.
Any question?
Hi, Stephen. Have you ever considered to put the IXML definition language in XML itself? Because I actually find it very weird that something that's called IXML doesn't use an XML input grammar.
It does.
It doesn't.
It does. Whether IXML uses IXML?
No, whether you can write your IXML definition in XML. You can't.
In XML. Oh yeah, you can do that as well. That's permitted. You can just write it straight in XML. Not all the implementations accept XML input, but there are some of them do.
But it's defined somewhere.
Sorry?
The XML is defined for the input.
Absolutely, yeah. In fact, it's the XML form that's the definition of IXML.
Okay, thank you.
I just wanted to point out that not only can you describe the format for XML in XML, IXML in XML, Michael Sperber McQueen has also written a schema for it, so you can also validate it using RelaxNG.
Coffee. Hang on.
much to come back there. I think there is some rules about coffee in the room, but I forgot it. Maybe Yeka remember it properly. Are we allowed or not?
Coffee room, I don't remember anything.
You don't remember, okay. That's it. That's the rule. This is the way. So the presentation. So I want you to introduce our twin sister. We can say now. It's more than sister. We're twins now. Twin conference, which is what's the name actually? Is it okay? You tell it. And which happens to be in Brittany. No, what's in an island somewhere in the UK. Yes, exactly. So please.
Right. So only Mum can tell us apart these days because we're twins. We are the older. No, we're not. Actually, we're the prettier twin. See. Anyway, this year it's all about XML Prague. Next year, about the same time, so the first half of June, in the UK, in London, there will be a new edition of Markup UK and not XML Prague. So this is obviously quite confusing. And so we are here to answer any questions you might have about this later on. Now, tonight, there will be a demo jam, and one of the prizes, by far the best prize in my esteemed view, is a full pass to next year's Markup UK. So, and for anyone attending tonight's social dinner, there might even be some other surprises. So attend, make sure you're there. All right, anything I missed? Okay, so thanks and see you next year.
Thank you. Yeah, Kai, you wanted to?
Yeah, we have one more thing which we would like to share with you. I will do a few clicks here to show you image of this gentleman. Probably many of you know the Liam Quinn. He had spoken here several times and it's well known in XML world. Unfortunately, he got cancer recently and he's running campaign to cover some expenses. So we decided to help him a little bit. So if you will send some money to this campaign during the conference time, you can obtain some vintage XML Prague t-shirts like this. So just send some money to Liam using this campaign and then just visit the registration desk, and there is limited number of those t-shirts, and we also have few t-shirts from 2018. So thank you very much. And if Liam is watching us, hi Liam. And just to make it easier for you, if you will just go to the XML Prague homepage, there is a link to the recent post, and in this post there is a link to this campaign, so you can easily find a link to support Liam. Thank you very much.
Thank you. So now let's move to the first presentation of the second part of the morning about expression elaboration by Michael Kay.
Thank you. Is this working? Good. I'm Michael Kay. I'm the founder of Saxonica and developer of the Saxon product, which I hope you're all using, and if you're not, we'll have to change that. I'm talking today, and I apologize for being the fourth old man in a row to be speaking to you. But the term elaboration here is a bit of homage, as they say these days, to Algol 68, which was the sexy new technology when I started in the business, and is the way they described expression evaluation in effect. The talk is about trying to find a new and better way of evaluating expressions that brings together the benefits of code generation with interpretation, which are the two ways we do it currently. And I'm going to start by talking about interpretation and code generation and the advantages and disadvantages of both. So let's start with a warning that this project hasn't so far been 100% success. We've learned a great deal from it, and we've got benefits from it, and some of them weren't the benefits that we were expecting. And I think it's useful at a conference to share what we've learned and share what works and what didn't work, and to also share some of the things that we still don't understand about the results that we're getting. So the warning symbol says that there's roadworks ahead. It's not a clear route to the end of the tunnel. So expression trees. We've had introduction from Stephen this morning about how you can parse things into trees, and I'm sure the concept of parsing into expression trees is fairly familiar. Here's an example of a simple XPath expression, a comparison expression involving comparing the variable $x with the result of an arithmetic expression, and you build that into a tree of constructs. And it's the job of the parser, the compiler, to create an expression tree like that. And we're now concerned with what happens to that expression tree from then on. Yeah, I won't say any more about that at the moment. So if you're interpreting an expression tree, then in pseudocode, what you have is a class. And in an object-oriented language, you have a class for each kind of node in that expression tree. And each of those classes has an evaluate method. And the evaluate method, in this example, it takes some context object, which is what you get as a handle for all the variables and the context item and things like that. And the implementation of that evaluate method embodies the semantics of what that expression actually does. And if it's a comparison expression, that it evaluates the operands and then it compares them. If it's a variable reference, then it looks up the value of the variable and returns that. If it's arithmetic. So I've simplified it obviously by delegating most of the work in this example to a comparator object or a calculator object. Yes, Stephen?
Is the comma in the third line a mistake?
Yeah. Oh. Thank you. Yeah, that's a dot. But it's only pseudocode anyway. It's only pseudocode. This isn't the real code. The real code is obviously far too long to put on the screen. But a couple of things to draw out there. Firstly, the first thing that each expression has to do is to find its operands. And actually finding the operands on the tree is a lot more work than we would like. And the reason for that is that the tree that we use at runtime is the same as the tree that we build at compile time. And the tree we build at compile time has an awful lot of information about types and inferences and options that aren't actually used at runtime. And the tree is designed so that we can do manipulations on it, and that involves a data structure that's actually more complex than we would like to have at runtime. The second thing to draw out is that this is very highly polymorphic. So we've probably got, a couple of hundred different expression types. It's something like between 100 and 200, I think. And they all have an evaluate method. And so you need to, the performance of this, and I should stress we're talking about percentage points in performance here. Someone told me once that the world economy, the world GDP can be boosted immensely by finding a 1% improvement in the process for producing sulfuric acid. And we're a little bit at the stage now with XSLT where it's a bit like producing sulfuric acid. It's something that everyone's doing, and a 1% improvement actually is something worth fighting for because of its multiplier effect. So we are looking for small improvements now in a mature technology. That's one reason why we're now looking quite closely at the way Java actually executes our code. And the way that Java handles polymorphism is part of that. We've been doing a lot of detailed looking at exactly what the just-in-time compiler in Java does with our code and how it handles the polymorphism and whether there are ways that we can improve that. This is what they call megamorphic. Megamorphic means you haven't just got 3 different implementations of a method, you've got hundreds. And the way JIT handles that it does impose a significant overhead. I'll go through this slide very quickly. I've taken this isn't the full expression tree that I showed earlier. This is a very simple expression minus $x. So you've got one operator and you've got a variable reference. So there's 2 nodes on this expression tree, and the bytecode for the first part is evaluating $x, and the bytecode for the second part is evaluating the unary minus operator. And that's actually real bytecode. That's what we generate, except I've added the comments, and I've abbreviated it to fit on the line length. But what we do is we load the context onto the stack. We invoke a method to get the stack frame. We then get the 0th element of the stack frame. We've calculated in advance that this particular variable $x is going to be at position 0 in the stack frame. And that's getting the variable, so sort of 5 instructions in bytecode, and then another 5 instructions to do the unary negation. But most of the work here is actually calling a method in the runtime library called the negate method. Actually, that negate method is 1 line of code. And what becomes significant in Java execution is that line of code can be inlined, because it's a very simple method, the negate method, and inlining it actually reduces the overhead, because it means that instead of 1 instruction to do the negation, you've got about 6 instructions to do the function call before you can do the negation. So the overhead of finding the code you want to execute is what ends up dominating both the bytecode case and the interpreted case. And it turns out that actually we've already, one of the spin-offs we got from this exercise was discovering that code can be improved. And the way it can be improved is by, instead of casting to a numeric value, we actually know from our own type analysis that $x is going to be a double value. And so we can actually cast to a more specific type. And if we cast to a more specific type, then the JIT compiler isn't polymorphic anymore. It knows that there's only 1 relevant implementation of the negate method, and it can inline that and avoid the polymorphic method call. So you really have to do some very, very precise analysis as to what's going on in order to find those micro-optimizations. So what's the problem with interpretation? Well, half the time you're spending deciding what to do rather than doing it. You are walking around the tree, you're examining conditions at runtime that you could have known at compile time were never going to be satisfied. We do as much as possible of doing that work early if we can, but there's still a certain number of things that you do at runtime that are unnecessary because you could have done them early. Navigating the expression tree is a cost. The code is very highly polymorphic, as I've mentioned. And the other thing is that you get poor locality of reference. So the performance of modern hardware doesn't depend on how many instructions you execute. It depends on how much data you transfer between the main memory of your computer and the CPU. So it's the memory bandwidth between it's the bandwidth between the memory and the CPU that really determines performance, not the number of instructions you execute. And for that, getting locality of reference with your data, so that if you pull in 1 bit of data, then the next bit of data is likely to be in your cache already, is important. And the other thing that's important is the pipelining of instructions. So the processor can predict what the next instruction is going to be. And it turns out that both of those things are actually quite poor with an interpretive structure like this. On the other hand, what's the disadvantage of bytecode generation? Bytecode generation has the advantage that we bring together the code for a whole expression. So as we saw with the -$x example, It was bringing together the code for evaluating $X and the code for evaluating minus into a single lot of Java code with no overhead calling one from the other. So we were doing our own inlining of the code to create a single method for the expression. What's the disadvantage? Well, actually generating the code is expensive. So we end up doing it very selectively. We identify the hotspots. We only generate byte code for the hotspots. That involves its own overheads as to monitoring what code is being executed most frequently. There are a lot of sort of operational issues with the fact that if we do too much bytecode generation, we run out of memory. We hit limits on the size of methods or classes. So we have to do a lot of sort of failure management to make sure that we don't fail because of those limits. Debugging the stuff is an absolute nightmare. I mean, I do not like it when people find bugs in the bytecode. I don't like it when I make a change to the bytecode and it doesn't work, because it means you've got 3 hours working out what on earth is going on. That means maintainability is difficult. As the product develops, keeping the bytecode up to date and working functionally is hard work. And then the focus of this project is the problem is that bytecode only works on the Java platform, so it's very Java specific. And finally, the bottom line is that the performance benefits of it are actually quite modest. If we'd known what the performance benefits of doing bytecode generation were before we started, then we'd have never done it. Because it's only giving about 30% in the best case, 5% in a lot of cases, and 5% is certainly not worth the investment we've put into achieving it. On the other hand, having done the work, you don't want to throw away that 5% and throw away your work. So we were looking at alternatives. Now the background for this project, why did we want to re-examine this? Why did we want to rethink what we were doing? Was Saxon on the .NET platform. So until Saxon 10, we built a product on .NET by converting the Java product using technology called IKVM, which translates Java bytecode to .NET bytecode, in effect, at that level. And because that technology worked by translating at the bytecode level, it actually magically converted the bytecode we generated as well, which was astounding to see that working, because we didn't have to do anything to make that happen. But we could actually generate bytecode for bits of the expression tree, and IKVM would, on the fly, translate them into .NET code and execute that. So we got bytecode generation for free on .NET. The problem was Microsoft pulled the plug on .NET Framework and announced that the future was .NET Core, which is all the same APIs and architecture, but it's a completely different implementation underneath. And it meant that IKVM stopped working. And IKVM is one of those open source technologies that's developed by one person, Jérôme Freitas, who spent 20 years of his weekends developing it and eventually got bored with it and decided to stop. And we're always exposed to the risk of developers losing interest in what they're doing. And that's what happened. So we had to find a new way of doing Saxon on .NET. And what we did was we wrote a source code transpiler from Java to C#. And I described at Markup UK last year how we wrote that transpiler and of course we wrote it in XSLT. How else would you do it? Transpiling one language to another is just a question of taking the syntax tree, turning it into XML, doing an XML transformation, and then serializing the XML as a different language. It's simple, isn't it? But the consequence of doing that was that bytecode stopped working. And so this project was to say, is there something we can do instead to compensate for the fact that our .NET users have lost bytecode generation? Is there something else we can offer them in lieu? This picture is me having a bright idea and my colleague saying, "Are you sure?" So I thought I'd try out this idea of expression elaboration, which we'd used on the JavaScript project, and it had been extremely successful there. so it having been very successful with JavaScript, I thought, let's see what happens if we do that in Java and C#. So what is expression elaboration? Well, the first time we visit an expression at runtime, what we do is we take that node on the expression tree and we convert it to a lambda expression, to a lambda function. So we generate a function that takes the context as input and produces the value of the expression as output. And part of that is that we do the same on its, the closure of that lambda function, the data that it has accessible to it when it executes, includes as much as possible of the data that we need as execution time as possible. So we're trying to minimize the work done each time by maximizing the amount of the work we do first time through. And part of the work we can do first time through is to elaborate the operand expressions. So instead of a tree of expressions in our expression tree, we end up with a tree of lambda functions that invoke the function for a parent expression will have the functions for its child expressions in its closure. And then and perhaps if I show you the code, it makes a bit more sense. So here's an example, taking the negate expression again, unary minus operator. This is real code. No, I think I abbreviated it very, very slightly to take out some of the stuff that I would otherwise have had to explain. But it's essentially, it's not greatly abstracted from the actual real code. So we start up here by saying what expression are we. So this code is first time through code. We do the elaborate function once the first time we visit a node in the expression tree to execute it. And the top half of that is evaluating some variables which end up in the closure of the function that we generate. Now there are three paths here where we generate a lambda function. There's this path, and there's this path. So depending on the input conditions, we generate a different lambda function. If we know statically that the result of that $x might be an empty sequence, that affects the semantics of unary minus, and it affects it in a way that depends on whether 1-0 backwards compatibility is in force. So if it may be empty and if it's backwards compatible, then we generate a function that's going to generate double-valued.nan if it's empty. If it's not backwards compatible, then we generate null in that case, which is our representation of an empty sequence. And in the common case where it's not going to be empty, then we ignore all that runtime logic of saying, are we backwards compatible or not? And we just generate a simple call on the negate function, which is the same function that the interpreter called. And our hope is that that negate function is going to be inlined by the JIT compiler so that all that access to the closure of the method and so on all ends up. And the hope was this would achieve something very comparable to what we achieved with bytecode generation. There's one thing that we missed, and that I think accounts for some of the results that we've seen, which basically are that it's not as good as bytecode generation. And that's the fact that we are generating the same lambda function. This bit of Java code handles all unary minus operations in the entire style sheet. It generates a different lambda function in each case, and those differ in that they have the same code, but they have a different closure. And what seems to be happening is that the JavaScript compiler is very good at recognizing I've got two lambda functions with the same code but different closure, and I can optimize those differently. whereas Java is saying it's the same code, so I'm going to generate the same optimization for it and not take too much account of what's in the closure. So this is a tentative conclusion, but I think we're seeing a difference in the way that different language compilers are optimizing Lambda expressions under the covers. And that's, work still to be done to determine whether that hypothesis is true. So the results that we're seeing, with JavaScript, we were getting a 5 times improvement from this kind of technique. 5 times, we didn't really measure it. You could just see it. For a 5 times improvement, you just see it go past. You say, that's okay, I'm not going to waste time measuring that. It's obviously faster. For C#, we're seeing 10% on some queries to 25% on others. So actually, it's the same order of improvement that we're getting with bytecode generation on Java. And since C# was perhaps the main focus, we can count that as a success. But what we're seeing on Java is hardly any improvement at all. And we've been doing a lot of work to try and find out why that should be. And we haven't got a complete answer to that question yet. Why do we think there are differences between platforms? Well, with JavaScript, one of the reasons was that we were starting from a much lower baseline. With Java, we've spent, 20 years almost refining the way that interpretation works and the way bytecode generation works, and they're pretty sophisticated, and an awful lot of optimizations have already gone in there. Whereas with the JavaScript platform, we were starting from something that was much simpler and didn't try to optimize anything. So that's perhaps one of the main reasons we got better success there, starting from a lower baseline. But we also think, it looks to me as if the different language processors are handling Lambda functions differently and doing different optimizations. And the significance of that is that you really need to understand the low-level machinery that you're using in order to get performance benefits at this kind of level. Measurement is so critical. Everything depends on measurement. As I say, to spot a 5 times difference, you just use the naked eye. It obviously goes faster. To spot a 10% difference, you don't need to be very elaborate in your measurement machinery. Some fairly simple measurements will show a difference of that kind of order. To spot a 1% difference, you really need to look hard, because getting Java performance results repeatable at that level of precision is really hard work. Don't try and do it on your laptop, because your laptop speed will vary by up to 5% depending on the temperature. If the room gets warmer, then the laptop is going to get slower. And that's even without the virus checker kicking in and an email arriving and processes being swapped out. It's normal to get differences of up to 10% if you do crude measurements on a laptop. So you really need to do very careful benchmarking with a machine in a controlled environment, and you need to run for hours, not for minutes. Getting that sort of accuracy of measurement really requires very, very detailed work. And the benefit is that you actually discover things you weren't expecting. So the real benefit of this project has been that by doing the measurement to find out whether this technique of elaboration worked, we actually discovered lots of other things that were much easier to fix and improve. There's this cycle that I draw there. If you measure what you've got, you understand why you're getting the measurements, and then you make improvements. And if you spend a lot of investment on measurement, you can often find there's some very easy ways of making improvements just from having the data and understanding that data. There will always be low-hanging fruit, regardless how many years you've been tweaking things. And that's certainly what we found from this exercise. So conclusions. Well, for C#, we're seeing enough benefit to suggest that it's worth putting this technique into production. Unfortunately, I was hoping that the technique might be good enough that we could get rid of bytecode generation on Java. That doesn't appear to be the case. Users wouldn't thank us if we got rid of that facility and they saw a 20% slowdown on their workload as a result. We've learned an awful lot about benchmarking, and we've been able to use some of that knowledge to get performance improvements in other areas. So that's it. Thank you.
Thank you very much, Michael. We have a few minutes for question. Any question? Yeah. Yeah, look up.
So, you've put quite a lot of work into doing this. Why didn't you just take that, whatever it was, IXML or whatever it was called at the beginning, that's the implementer stopped working on, and just take it over and fix it?
Sorry, take what over?
That thing that converted bytecode to bytecode.
Oh, one of our customers has actually attempted to do that. And we decided to keep a watching eye on that project and see how they got on. And they were struggling with it. I didn't think it was a good idea to attempt, because although the product was IKVMC was open source, there was no test material. And I don't fancy changing a complex bit of open source software like that without any test material to check whether the changes I've made will kill it. So no, it didn't. And I had no idea of the scale of the task, because we don't understand .NET bytecode and all the things it's doing well enough. So, yeah.
Another question?
Thank you. So you handle C# and Java differently. How is this handled by the transpiler from Java to C#? Is there a lot of extra code to do the elaboration stuff in C#?
No, that part is actually very common. One of the interesting things in doing the transpiler was to discover that there are some things that are very similar between Java and C# at source level, and there are some things that are quite different. But actually, Lambda functions are very, very similar between the two languages, and therefore there's a few differences in typing, for instance, on arguments and things, but by and large, converting Java Lambda functions into C# Lambda functions was very straightforward. Yeah.
One more question?
I was wondering if you've looked at what other implementers of dynamic languages on top of the JVM have done in terms of some of these implementation things. I was specifically thinking about the improvements the JRuby people were able to get in a lot of probably not entirely unrelated areas with things like invoke dynamic and other.
I'm sorry, I'm having trouble following with the.
So other implementations of dynamic languages on the JVM.
Right.
Specifically, I remember that JRuby were able to achieve significant performance increases with certain tricks that became available.
No, I'm sorry, but the answer is no, I haven't looked at it. But thanks for the suggestion.
So we have time for one more question?
You hinted that the benchmarking and measurements that you did found a number of other opportunities for performance improvements. I just wondered what some of those were.
The way we found most of them was actually looking at allocations of objects, in particular allocations of objects that weren't immediately garbage collected in the sort of very local garbage collection that the JVM does nowadays. We found some gross bugs where we were allocating things completely unnecessarily that turned out to be on paths that were executed much more frequently than we thought they were. One of the things we've looked at more recently, we've put very little performance attention comparatively into the Saxon compile time versus the runtime. We've tended to focus on runtime performance and tended to assume that compile time is free because it's amortized. That's not true for all workloads. there are workloads where compile time is completely dominates over execution time. So profiling some of the compile time, we've found things that, have been lingering there for years because we've never really looked at that hard.
Okay. Thank you very much.
Okay, thank you.
By Antonio, and he will be presenting a benchmark collection of deterministic automata on XPath queries.
Is it working? Do you hear me well?
Yeah.
Okay, great. So today I'm gonna present a benchmark collection of deterministic automata for XPath queries. This is a joint work with Joachim Nieren done at INRI Alil in the context of my PhD thesis. So next in the presentation, I'm just gonna go through. Okay. Okay. So I'm gonna go through why we did this work and why we did the choices we made along the way. Then pass to how we did it, and finally, if there is time, I'm gonna present quickly the benchmark results. So first thing first, why XML? Our main objective was to obtain small deterministic automata to be used in automata-based streaming algorithms for structured or nested data. And what better than XML as a candidate for that purpose? So there has been extensive work and research on XML stream, whether for validating, sorry, querying and transforming XML stream using XPath, which is the core language of the languages for XML data processing, like XSLT and XQuery. You can find a wide range of theoretical results there with different complexity and different coverage. So most approaches work fine in memory evaluation, but when it comes to streaming mode, it becomes really tedious, especially when it is syntax based. So the second why is, why did we choose automata? Mainly it can provide a full alternative to syntax based approach and most of the other approaches, and they are easy to obtain from regular XPath queries. So algorithmically it's a bit tedious, but computationally it's easy. And most importantly, it provides the largest coverage of XPath evaluation on XML streams. I'm gonna cite a few works quickly here that used automata. So the one of Olteanu that used transducers, which are automata with some output tape. The work of Muzaffari in the context of
complex event processing of XML streams. And lastly, the work of Sebastian Nieren and Mr. Zarqawi. So mainly, one thing to mention about this last work, it used networks of nested word automata, and it covered almost with few minor exceptions, full XPath 3.0 at that time. Okay, so we chose automata. Why it has to be deterministic? So for simple reasons that it has a better complexity in solving algorithmic problems, in particular universality problem, which is the problem that we are interested into. And the ability to obtain unique minimal automata, of course, up to renaming the states. And there is also a lot of work in this direction using deterministic automata. I'm gonna also cite a few. So like the one of Gauvin and Nieren, they also used, sorry for many automata models, they also used the nested word automata, the work of, a more recent work of Schweigart, which in the context of evaluation on compressed documents. And the most recent one is, this year, is of Reveros, where they used visibly push-down transducers that extend on visibly push-down automata, and provided the solution for enumerating answers on streams of nested documents like XML or JSON in what they called output linear delay. So if determinism is our best or our better solution, what's the problem then? Well, they are actually difficult to obtain. And this is because computationally they come with a high complexity, they are exponential. Sorry. They are exponential in the worst case. So when our colleagues back then in the works I mentioned tried to compile XPath queries, even simple ones like descendant A/descendant B, there was a huge blow up when constructing this automata in the size of millions. So you can clearly see here, for example, this query that is relatively simple. It will give us an automata of size 20 million with 5,000 states. So after that, we used another approach where we could convert nested word automata to stepwise hedge automata. So it's another model. Determinize it and go back to nested word while preserving determinism. We were able to obtain the needed small deterministic automata for the whole regular part of XPath mark benchmark. But again, when we started to go a bit further from this benchmark and test other query, the blow up came again. And so here's another example of a query that we tried to compile directly to stepwise hedge automata. And it went up to 1.6 million in size with 10,000 states. So we needed to find a solution to have this automata small to be manageable. Well, the key thing was to use the schema, which I'm gonna show next. After that, sorry. So, as a contribution, we provided a collection of deterministic automata for the regular part of Flick's and Schmidt's benchmark. This is a practical benchmark where They extracted XPath query from different online programs like DocBook, HTML Book, TEI, and all of it, more than 20 programs. It was around 21,000 queries. So the regular part of it, it's 4,500. We used a recently proposed technique to include the schema in the process of determinization and applied it on the stepwise hedge automata. And we tested our automata for correctness relatively to Saxon. So let's get a bit into details because too much storytelling before. So I mentioned the universality problem before, and it was for a reason. So if we can take this simple example on words first, and for those who are familiar with the finite state automata, this should be straightforward. Is it okay? Good. So this query is mainly saying, verifying if a word contains a letter A followed directly by a letter B, that is followed eventually by a letter C. And this is the automata that represents this query. So a run should start at initial point, initial state here, read the letter a state by state, so we start at 0, and then move depending on the letters. So here comes the run reaching C. So we started 0, read 1 at A, read another one, we remained at 1, read another A, sorry, we remained at 1, read it a C, we went back to 0 because actually we are waiting for an A directly followed by a B, read a A, read a B, and then read a C and reached state 3. So state 3 is what we call a universal state, and this is our stopping condition for an algorithm, whether it's for a Boolean query or for a query that is selecting nodes. So once I reach a universal state, I can decide that, okay, I have an answer for that query. And this is why we are interested in this problem, because in case of deterministic finite state automata, it can be done in linear time, where it is space complete in the case of non-deterministic. And even the non-deterministic case gets worse when we go to nested words or nested structure like XML and all of it. So I kept saying nested words, nested words, nested words, automata. So the nested words are actually the are actually the abstract model that we use in order to compile XML to it. It's fairly simple. It's actually a well-bracketed word, but our notion of nested word, excuse me, our notion of nested words is a bit different in the sense that it is not tagged. Instead, we rely on words from the signature with the concatenation operator. So if we're gonna represent XML like a nested word, it would be like this. So firstly, the document node that's almost everywhere. And then an opening bracket, LM site. Then we open a bracket, LM closed auctions. And whenever an element ends, we close the brackets accordingly. So since once we have nested words, we can use all the machinery we have from Automata and others to work on it in the literature. So our choice of automata was stepwise hedge automata. It generalizes on both words and trees, and therefore on sequences of nested words. It can read sequences of words, trees, and so on. It avoids top-down determinism, so the blow up, it's, let's say, less severe. It has the same expressiveness as nested word automata. And the universality checking, so the universality problem there can also be decided in linear time. So it can be a possible alternative for streaming algorithms on nested words. Here comes one stepwise hedge automata. I'm not gonna explain the model on this one, but on the one next to it, the one representing the XML model. But just to say, this one is just for variable binding, so it allows to bind a variable x once, and we're gonna see how in the next slide. So this is the automata that represents the XML model and allows to select nodes while running. So for the part that is still in color, so let's start with the first branch here. So this branch is what we need to read an XML attribute. So again, if you are familiar with finite state automata, you are halfway there. So we start with a 3 initial states, so it's actually opening of a nested word. We read the type attribute, any namespace from the signature, so it's the prefix of the namespace, any name, which is the local name of the attribute. Then here, we either bind a variable for selection, if we're gonna select this attribute for the query, or we don't bind it, so 2 paths. And we end up in what we call, okay, and also read the value of the attribute in a series of characters. And then we end up in what we call 3 states. So this is new normally from finite state automata. So here the whole branch read a whole nested word of type attribute. It ends whether in 24 and 23. And this is how it becomes relevant next. So back down to the down branch. So we are now reading an XML element. It goes the same way, type element, prefix of namespace, any name, local name, either bind or not bind the variable. And if you can see here on state 16, you have a transition 24. So this actually means that here I can read a whole tree or a whole nested word that could be evaluated of state 24, which we just saw earlier. It means I can read an attribute here. And you can continue like this. So the whole automata here can represent a document that can be run with this automata correctly and accepts. It means it's well formed and it can select nodes during the run. So let's see quickly the compilation chain. So how did we obtain this automata? So here comes also a simple XPath query, which is selecting a node called body that has an attribute length that is not empty. So we first compile it to nested regular expression. So regular expression are there since decades. I'm not gonna get into details, but what I need from this is to notice that after like the type LM, the namespace H, the name body, we have here this variable X, which is marking that the node body, this node body is to be selected. So this query will actually give us or detect the body node. And now, so here comes the nested regular expression that is compiled to our stepwise hedge automata. This one is non-deterministic. So next we're gonna see something ugly. So since we are in a beauty context here. So this is the automata that is compiled directly without any schema, determinized directly without any schema. So it's not supposed to be read, but just to show how ugly it is. It's the right amount of ugliness that fits in one slide. Actually, this is not very big. So I think tens of states and maybe some hundreds of transitions. But when it goes up to millions and you need hours on a simple laptop to get such an automata, it's practically unusable or useless, let's say. So, and here comes the beauty. So this one should win. This is the same query, but we integrated the schema within the determinization process. And we were able actually to obtain really small automata. And if I reach it, I'm gonna show the result at the end. So here comes the results, the setups. So the benchmark setup, we first compiled an XPath query to stepwise hedge automata, so this A here. Then we attempted to determinize it. After it determinized the product, so the query automaton with the schema automaton, so XML model schema we saw before. Surprisingly, we thought that it will also explode even more than the query alone, but it didn't. We kind of have an intuition why it didn't. Here comes the determinization using the schema with the approach I talked about earlier, schema-based determinization. Then we minimized both of them. I'm gonna come next to minimization. And finally, we compiled it back to nested word automata. So before going directly into the result, just few words on minimization. So minimization algorithms for automata already exist for the finite state case. They can be lifted to stepwise hedge automata, and the resultant automata is actually unique under some prerequisite properties that I'm not gonna get into it. And we did implement the minimization algorithm also to further reduce the automata that we obtained. Sorry. So finally, here comes the result. So in the first, so this is let's say 4 or almost 10 queries of the full benchmark from the paper. The first column represents the size, and as I said before, inside the parentheses are the number of states of the query directly compiled to non-deterministic automata. They are not relatively that big, but still hard or big enough to be determinized. And because next you will see when we attempted to determinize them, so the empty boxes here, we could not obtain this automata with a timeout of under 100 seconds, if I recall correctly. So 70%, 37% of them were not computed. Next, as we said, sorry. We determinized the product with the schema, almost done. And they were most of the time smaller, at least in the number of states. And next, here comes our schema-based determinized automata, and they were smaller, mainly roughly by a factor of 2 and most of the time. We minimized both of them with the minimization algorithm I just mentioned earlier. And the one with our approach mainly led to the smallest size, and it was an average, I think. So at the end, for the whole benchmark, we got automata with 27 state in average and 70 transition. And finally, we converted it back to nested word automata, which preserved determinism and were actually small. So just to conclude, so we provided the collection of deterministic automata from the practical benchmark. The results are free online for both stepwise hedge model and nested word model. We are working now on a streaming algorithm that it's in progress that is using this the stepwise hedge model, and as a direct application would be on XML streams. And we are thinking about the possibility of lifting these streaming algorithms to hyper streaming. And that's it. Thank you.
Thank you very much. We have 1 minute for some question. There.
I think that's really interesting. I just had a doubt about one thing. So it's the hedge automaton. So
it's a stepwise hedge automaton. So hedge automaton.
I just have a doubt about hedge.
Yeah. So
whether or not you meant edge.
So hedge automaton, I think you're talking about the work of Murata, I think. So there is the.
Just thinking about the word hedge, because it's because in French you don't pronounce the H's, and I'm wondering whether or not edge wasn't. Is it the edge of something, or is it?
So hedge. So HEDGE. So like a
so it
string
is a
of
hedge,
words.
it is in A.
Sorry, I'm not.
So I could be wrong, but I thought that maybe that there might be a confusion on that.
No. It's hedge with the H.
All right. So my mistake. Thank you.
More question? Okay. Thank you very much.
Thank you
very much.
Okay, you need this. Yeah.
This is the terrible position. So we put array, our SGML.
Oh.
SGML, something. So use the markup.
Sorry. Just trying to make things. Oh, and it does it again. Stupid thing.
Looks like a demo jam.
Yeah, I know. Right. And if I do, please work. Yes, it does work. Right, apologies for that mess. Me and computers. So, can everyone hear me okay? Good. I'm not going to comment the title just yet,
but let's just ask this philosophical question, why are we here? I don't know about you, but I'm really glad to be back live at XML Prague 2022. It is just so cool to be here again, okay? Just want to say that. So more specifically, so the past 2 years I've been working in sort of a kind of a new field, and so I encountered a little something that really pissed me off, to be perfectly honest. So this is sort of a rant in this day and age of angle brackets and mature technologies. So lately I've been working within product life management, or PLM, and they go around doing stuff with engineering data. You know, CAD data is also known as, and the theory is that if you have this thing called a bill of materials, which is shortened BOM, and for the longest time I thought, byte order mark, what do you mean? You know, shows where I came from, right? But anyway, the BOM, the bill of materials, is this group of items that together make up a kit, a product, a something. So you can have a BOM of BOMs and all kinds of stuff. I'm not really an expert, so I could be totally wrong and I could just be lying to you, but that's not the point here. But the engineering data, so it's these days it's used in all kinds of products to design your product. So it will contain lists of your parts and the groups of parts that are your kits or accessories. And with the right tools, you can use this engineering data to describe disassemblies of products and assemblies of products. It is kind of cool. So the theory being that if you're listing all of your parts, all of your kits, everything, that is a full product, whether it's an aeroplane or something else. Yeah, I mentioned that. And the really nice thing about this is that you can do so you can do your disassemblies and assemblies. You can do cool animations. You can use the engineering data to generate images. These explosions of kits. You've seen those in parts list, I hope. But you can also use that data to generate XML. So you can generate your step-by-step instruction on how to do a disassembly of something or the other. So it's quite cool. And this is where I came in, because I do XML and documents and angle brackets. And so the PLM world actually loves things like DITA and S1000D because they are topic-based. So they are ideal for being the target of those conversions from a disassembly in the engineering data world to a DITA topic, a DITA task to be precise. So you can see why they like them. They actually love them. They do. And so it goes without saying that they will use these topics, these generated topics, to build documents in a PLM product. So they cross over to this documentation world, this XML world, where I come from. But this is also where the problems start properly now. So let me just do a really, really quick DITA refresher, because there's a point to that too here. I don't know if you do DITA, any one of you. Not a particularly exciting standard, but it's all about topics. A topic describes a single subject. So that subject could be that assembly procedure. It could be a concept that describes the product, or it could be a glossary item or something else. They're building blocks. And what's important is one subject equals one topic. And they all look sort of like this, with some variations. There are task type topics, there are concepts, there are references, etc. Now, when you produce a document from data topics, from your building blocks, you use something known as maps. So all the organization, all the hierarchy where chapters and sections and subsections happen, all that happens in maps. If there are hierarchies, it's expressed in the maps. The topics know of no such thing. So this guy here, for instance, we can see a couple of levels, section levels, chapter, section, subsection. And if you actually produce it to a PDF, the table of contents might look something like this. So just a couple of levels, really. It's a data thing, but it's no different from all kinds of other similar standards. And again, I stress, topics are really building blocks, because if you do a different map and you use your same topics but in a different order, in a different hierarchy, like this simple one here, well, you use them differently. So, building blocks. And they have no relation to each other, right? Let's discuss the PLM product. Now, I'm not going to mention it by name, for obvious reasons, but let me just say that I'm not against that product as such, at all. It's quite cool, the things it does, but the crossover to the documentation world is what sort of interests me here. On the surface of it, there's this content management feature in it. So you do all the kinds of things you would expect from ECMS. You do single source publishing using, XSL-FO or XSLT to do HTML, etc. You have versioning, and you also include management of your data maps. So you have something like this. So this is quite a nice visual presentation of a data map in this product. You can see the same structures. This is the data map I showed you earlier. It's just an example. So what's there not to like, right? Because there's loads of features. Well, here's the thing. This is not XML at all. So this guy here has nothing to do with XML. What happens along the way is that they actually get rid of all the angle brackets for the maps. They import the graphics because those are references to leaf nodes. They do the same with topics, again leaf nodes. And finally they do maps. And, sorry about this process is known as decompose. Quite apt in my mind, but yeah. And this decompose, it happens every time you bring a map into this product, every single time. It's a process that is done using rules. There's an unfortunate naming conventions at play there because these people are not XML people at all. They call it XML attribute mapping, which is really, really confusing because it's not XML and it's not attributes. It is mapping though. Can you see that? Sort of, I don't know if you can see that, but the column to the right is a path, they call it. It always begins with a slash. There's an @ sign, so it looks like an attribute, right? So this looks deceptively like an XPath, except it isn't. On the left-hand side, there are database items, objects that you map this thing to. And in the middle, there's some kind of function, the thing you do when you map. The direction, for instance, if it's a decompose or a compose. And there are a number of these rules to be done. They even grab the document titles using these and put those, they display those in the structure view you just saw. So everything you do when you bring in a map needs to be described with this sort of thing. I'll discuss it in a bit, because there's a lot of it. But just to remind you, remember how maps create hierarchies, like this nested topic graph here, or another here, building blocks, right? So I did this experiment for, this is actually a client project, but I changed the names for obvious reasons there too. Look at the final several lines 10, 11, something. We have a section 2 nav title that uses topic D and topic E. And this is what it looks like imported. So it seems that the mapping works quite well. So I took this second map. Let's highlight that. It's exactly the same as the last one, except that I used one additional building block. I nested that inside topic E. So there's a topic F nested. And I imported that. And again, you get what you expect. So far, so good. Can you see this at all? You can see this is my first map, so the very first one. So if I go this one here, this is what it looked like before. Then I imported map 2, and it all went well. And look at what happens. Whoops, you don't want to do that. Right at the bottom. These are not building blocks. They're all related to each other in this system. Because every time I change a map, I import, you know, a different kind of structure, a different kind of hierarchy. This product actually changes all the previous maps using those topics, those nested topics. Inheritance in XML? Really? So what just happened? Well, and this is really my rant. We're mapping XML. Incidentally, it's called a map. And we're mapping that to a non-XML model. Happens to be a relational database. There's some kind of model there. In actual fact, the structure view you saw, it's a reused component from the engineering data parts. It's more of a generic component. Someone thought it was cool to have that tree view, which it is. But those two, so the map XML, and the database model, they're not compatible at all. The mapping language is not very powerful, but what's even worse is that it really, really looks like XPath, a sort of a bastardized version of XPath. So if you're an XML person, you sort of expect that to be XML, and you want to do predicates and conditions and all kinds of stuff when you're mapping, which you cannot do. So it's quite a weak language for the job. Yet, it is something that you need to use every single time you bring in a map or you export a map. Every single time. This leads to a bunch of other problems, obviously. So, if the things that aren't mapped to something in that XML attribute mapping thing, you know, the XPath-like rules that are not XPath, things will go badly wrong. For example, in a DITA bookmap, you can insert a TOC element. Now, the TOC element can be used in two ways. You can use it as a reference. So you point to an external topic that happens to be your table of contents. Or you can simply use it as a placeholder. So, you know, if you place a talk element, an empty element like that one there, it just shows, yes, I do want to generate a table of contents. Thing is that the mapping language doesn't allow me to create two rules for this thing. And I cannot do a conditional rule that allows me to, you know, either treat it as a reference, which is a special kind of item in the database, or just an element, an empty element that is a placeholder, which is sort of bad. Another problem that I discovered recently, you know how in Ditto you do profiling? So essentially it's just a bunch of labels separated by white space. So label 1, space, label 2, space, label 3. And it means that this particular element is applicable to these profiles. Well, if you want to do a set of profiles in this product, it uses internally an array, but when you compose your map and bring out your you know, XML and bring out your profiling values, the ones that were supposed to be separated by spaces, you get comments instead. And this is just a direct result of, you know, poor mapping and a really bad data model internally. And I could, you know, I could go on, because essentially a bad data model, well, an incompatible model at that, it just doesn't work if you need to go back and forth. I mean, those of you who've been doing markup for a while know that, well, this is by far not the first. Anyone remember Frame plus HTML in the olden days? So FrameMaker was a really, it still is, by the way, is a quite good word processor, non-structured, unstructured. It was used for quite large documents. It was quite popular in the 90s. And at some point, someone thought that, yes, we need to do SGML, this new cool thing. So they did kind of a similar mapping from their non-XML, unstructured format to an internally representation of SGML, actually. And then that one they then finally mapped to SGML. Wasn't very good. Always had problems, and you always had to do that mapping. This was a long time ago, as was this one. Anyone saw this? WordPerfect did actually do SGML once upon a time. Not many knew. It's a good thing that you didn't. More recent, maybe, some of the plugins before the Word document format itself became XML, where all these plugins for HTML and XML, they were all doing mapping at some level. They never worked, and so on. So, I mean, this to me is really like, you know, I used to play with Legos a lot when I was a kid. I loved them. I could build anything I want. And it sort of bothered me, you know, on a certain level, that when I got this boat, this ship hull, and it was in 3 parts, it was no longer generic Lego, but it was quite useful because I could, you know, do my ships, right? And it went on from there. So the Lego pieces would become more specific to your toy and, you know, less reusable. There's apparently a Titanic in Lego, and it's probably even less reusable because of that. And I just, you know, recently saw this. This guy is 5 meters or so. It's huge, made out of Lego. It's 1 million pieces or something. I'm not sure about the reusability, but that probably wasn't their point, to be honest. But this represents to me what happened here with the PLM product. You think you want to sell Lego, but actually you just want to sell a toy, be it a Harry Potter castle, which my kids loved in Lego when they were small. They built that, and they were all, you know, very specialized parts. They couldn't be reused anywhere else. So there's an obvious way around all this, because we already do have proper building blocks. Because the building blocks are not just, you know, the data topics and concepts and tasks and whatnot. They also, you know, the other stuff we have, and they all play really nice together. So, you know, we've got XML, that's 22 years old, I believe. No, it's 24 years old, sorry. So it should be quite mature. Similarly, there are loads of sister standards. You know, XSLT is only 20 years old. There's been several new versions. There's X-Forms and there's XPrague, and there are XML databases and XQuery, and you've got mature vocabularies, and you've got tool support for all of it. So this is really my point. Why would anyone want to do something other than XML when, you know, you should use XML? Thank you.
Thank you, Harry. Any question or remarks? Okay, I think everybody wants to go to lunch, it seems.
Good
Thank you,
choice.
Harry. Then.
Thank you.
So just a few information. So lunch is in the same place as yesterday. If you were presentation for Declarative Amsterdam?
Yes, Declarative Amsterdam. Most of you hopefully know Declarative Amsterdam, a conference that's still in the cold days of the year, instead of this hot conference that we're completely not used to. Show of hands, how many have virtually or physically attended one of the Declarative Amsterdam conferences? Excellent. Well, I have best news ever, because we have stickers, and you weren't able to collect them previously, or most of you didn't come. But now I got them here, and we'll put them on the table. But there's more news. There's the next Declarative Amsterdam conference, for which the call for presentations and tutorials is open. So feel free to submit. The conference will be held at 7th and 8th of November this year. I won't have to say in which city, I guess. And apart from the call for presentations, there's also a challenge, a declarative challenge. And the challenge is about writing an IXML solution. And there are there are 3 options from which you can choose if you want to participate in the battle. And if you don't want to sort of participate in the battle, but still want to show what IXML, a solution you've written, please post it and we can collect a list and make a short presentation out of that. So that's it. Oh yes, well, so far it's always been virtual. No, that's not true. The first one was only physical, and as the website declarative.amsterdam will tell you, it will be virtual, and it most certainly will also be physical, but we of course don't know for sure what the COVID temperature will be like in November.
Thank you very much. So now we have a 10-minute presentation from Stan. 10 minutes? Yeah.
From?
Say Stan or 11?
From?
Ah, yeah, from George
From?
Bina, of course. From George Bina!
Thank you, Mohammed. My main role is to wake you up after the lunch break. Okay. I'm happy to be in Prague again and to represent Oxygen XML editor and Synchrosoft, the company that creates Oxygen and the set of tools. And we grew in time, and we are, because I mentioned yesterday at the meetup that there are 6 people. There are 6 people here. Back in the office, we are more than 60 people. So there are a lot of people working actually to make these tools that hopefully you enjoy when you work with XML. In time, and I showed more details yesterday, we grew our tool from a simple XML editor to cover both development and authoring. And now, as my colleague Octavian presented yesterday, we cover also JSON and other formats with the same ideas that we implement for XML. Then we have some collaboration tools with the Web Author and the Content Fusion collaboration platform. And we did also some solutions on the publishing side with an engine that generates PDF based on CSS. And actually it uses under the hood the Apache FOP, which is nice because in a way combines the CSS idea and the XSL-FO as a technology. The web help and also a new solution, the feedback, which allows people to comment on HTML pages. Now, XML Prague has, I think we missed 2 of the entire set of XML Prague events in the first part, but we also always sponsored XML Prague even if we were not here at the beginning. And we did some interesting things along the time, including the angle brackets dance with keeping our hands like this. And also, some time ago, 8 years ago, I introduced the web authoring with a magic moment, and I will try to play that. So we have this camera that shows the two devices, the iPad and the Oxygen. And the magic part is that we need to get this document here, that this is a document, because we have also known here, so I choose notebook, not other type of document. So this kind of document that is rendered in Oxygen, and we have the track changes, comments, and so on. So let's try to get this on the iPad. And you can see what happens now. So it was incredible 8 years ago. And now we have the document on the phone. So as you can imagine, there are people like, I know there's a technology from MIT that, and it was very clear, it's a magic number, so everything was magic. Was no document passing from no device to any device. It was really just a trick to show the idea that the documents can go from one device to another, but still the web author worked on all 3 devices, only that it was not that seamless transition. Yes. There's no sun. Well, now back to today. We had this period of time when we stayed at home, and one of the things that we've done was to work hard on some of the functionality that we included in our products. And I just want to highlight that in Web Author and in Content Fusion, we implemented concurrent editing for XML documents, which in a way, I think, exceeds the idea that we presented 8 years ago, because back then we didn't show that you can edit the XML documents in the same time. So Content Fusion allows to easily share XML content, any type of XML content, like not only data. Usually we demo with data, but it works with notebook, with TI, or any XML document. And it allows concurrent editing for unrestricted access to the content. And let me see. So basically, you can just drag and drop a file, for instance, to this side view and upload it, provide a name, and where you say upload, and it goes on the Fusion server. And then I already did the same thing before. And then you obtain a URL that you can share with others. And you may decide whether you allow anyone with a link to access the content, or you can share with specific users. And once you do that, and you share that URL with others, then basically the same document can be accessed from iPad, from phones, from any device by any user. And let me try to access this now. So you can see basically typing in on what the user will see let's say, on my desktop when I'm typing in another device. And you can also see the other users. Of course, I'm now from the two devices, and so on. It was really a challenge for us to create this, because when you have a tree structure like XML, which is really constrained, and you are not allowed to make it not well formed, it's very hard to keep things when multiple people edit in the same time to keep everything and make sure that everything will stay well formed all the time. So basically, after you share this content, you back in Oxygen, you can integrate those changes. And you can see here that we show with the div what was changed. You can just say apply and bring those changes back into your document and continue whatever workflow you had. Yeah, so I didn't want to take too much time to show many things. Just one highlight, and I hope you will get a chance to try Content Fusion. A demo is available, and it's available without any cost for Oxygen users on fusion.oxygenxml.com. So if you are using Oxygen, you can also use Content Fusion to try to share content with others. That being said, thank you, and I want to thank also my colleagues, which are also here. Maybe you can show your hands. And if you have questions about Oxygen, feel free to get in touch with us. We usually have an Oxygen label or Oxygen branded shirts. So thank you again, and enjoy the rest of the conference.
Slides or keyboard.
Okay, I use the. Is there a laser point? Okay.
Yeah.
Okay, so I have to be careful to not.
Yeah.
And it's not showing on the screen. Okay, hello. I'm David. I do the talking, but the presentation was created together with Tony Graham, Andrew Sales, and Eric Siegel. Sadly, Andrew can't be here today, but Eric and Tony is. And I would like to provide a summary of, well, we call it the State of the Union, the state of Schematron as a standard, as a standard. The first slide is the one that's hardest for me to explain, so I try. If you have been at this conference before, then you know that since 2017 there were Schematron user meetups. And they were originally organized by Tony and Andrew. Later I joined the two, and later Eric. And we organically somehow started to maintain what, well, I would call the community infrastructure. This means organizing the users meetups. This means providing a mailing list, providing a GitHub organization. We had an existential crisis and asked ourselves, who are we for? We're not just for individuals. I think the most fitting description is community representatives. It's important to understand that this is a descriptive title. It's not something that comes with any benefits for us. It's what we do. And we choose to think of us as the Schematron editorial board, which what I learned is a reference to the SGML editorial board, a group of people who care about the community or about Schematron in the bigger picture. You can meet us, of course, today. You can also come to the this year's users meetup, which is held tomorrow at 9:40. So now you know who we are. Let's get started. What I would like to do is I would like to give a really short summary what Schematron is, then give a perspective on what happened in the world of Schematron in the past, let's say, 10 years, really short. And we'll finish with some thoughts about what will happen with Schematron in the future. For the ones of you who don't know, Schematron is a schema language for rule-based validation. It's part of the ISO's document schema definition languages, DSDL. And Schematron lets you check arbitrary parts of your documents against any number of arbitrary business rules. In practice, Schematron implementations use XPath to select parts of your documents and use XPath as language to evaluate the rules. There are three basic elements in Schematron. There's an element for the assertions, contains a human readable assertion and has a test attribute with an expression that tests if the assertion holds true. There's a rule element that groups assertions and provides the context for the assertion tests. And there's a pattern element that groups rules that are related in a user-defined way. This is a really simple example of a Schematron. It's taken from a digital scholarly edition. Line 3 is the pattern. You see there's a rule that says the following tests apply to RS elements with the type attribute of person. And the assertion is that there is a ref attribute on this RS element, and the ref attribute points to an element that is of the type TI person. And for example, not something else like a place. It's straightforward. Schematron is way more than just these simple things. Schematron provides element or constructs for schema reuse, for schema composition, supports localization, message templating, templating of rules, and also includes its own simple schema documentation language. It's a jack of all trades in some way. Why would you use Schematron? One, it's an ISO standard. This may be something that you need to tick off, or that may be an argument. More importantly, it lets you express functional dependencies in your documents that you can't express in other schema languages. Schematron implementations are built on top of well-matured technologies, in most cases XSL-T and XPath. Maybe this is also an argument. Schematron has been around for more than 15 years. It's heavily in use, so it has warts. I will come to some of them, but it works, and people are using it. There's a quote from Rick Jaliff. Rick was is the initial inventor of Schematron, who said it, I think, really good. It said, Schematron is a feather duster to reach the corners of that other schema languages cannot reach. Yeah, it's a nice summary. That's Schematron in a really short description what it is. It doesn't. Okay, let's come to the Schematron community. First, start with a really short timeline of what happened in the world of Schematron. I'm not elaborate, just listing. I'm not reading all the points. We have the late 1990s when it all started. 1999 was the first implementation in XSL-1. The idea of Schematron goes further back. We had 2006, the first edition of the ISO Schematron specification. 2016, the second edition, and 2020, the third edition. And since 2017, we have always had a users meetup at XML Prague. At the start of the users meetup, we make some kind of market research, who uses it. And if you ask who uses Schematron, the answer is almost everybody. Almost every industry uses Schematron for the most different tasks in finance, healthcare, in the publishing business, the digital humanities, in libraries, for every kind of task that has to do with rule-based validation or reporting. What I personally learned is if you meet someone who processes XML in a larger and smaller quantities, and who does quality control, you can be pretty certain that they use Schematron. It's a great tool. As I've said, we meet at XML Prague, or some of the community meets at XML Prague tomorrow, 9:30. If you want to learn about Schematron, there is a mailing list, the Schematronist mailing list, where you can meet other people that use Schematron. There's the homepage of Rick Jalif, the original inventor, who has collected a lot of information about Schematron, covering, well, starting with the beginnings. There's a GitHub organization where we four of us started to collect Schematron-related materials. Especially, we started an awesome Schematron repository where we try to provide a systematic overview of things that are done with or for Schematron. If you look back, or I looked back 4 or 5 years, publications about Schematron. They range from Hillman and Lissy, who discussed quality control in journal publishing, I think it was. You have publications from the digital humanities about a Schematron quick fix. This is an extension to Schematron. All the way down to a book about Schematron that will be published this year and written by Eric. September 2020. Now, 2022, oh dear. There are also new ideas or new features that are discussed in the wider community. There's an implementation that tries to match or to implement Schematron for JSON validation. There are thoughts about using the XSL-3 streaming for Schematron. And there's, for example, an article by me that discusses a problem with the Schematron language. We four, the four of us, started to collect all these ideas. So we created a repository that we call the Schematron Enhancement Proposal Repository, where we started to collect the things that are floating in the wider or closer community. We create an issue for something that we think that needs to be enhanced or corrected. We use labels to make a distinction between corrections of the specification text, clarifications that are required, or new functions or enhancements that could or will be useful in future Schematron versions. We accompany the issues with wiki pages that have a longer description about what the problem is, what the proposed solution could be. For example, I've picked some. If you use, that's the simplest one. That's an editorial error in the specification. There's just an error in section 3.13 of the 2020 specification that should be fixed. So these corrections are, well, editorial corrections. There are parts of the Schematron specification that needs to be clarified. And I think the biggest elephant in this room is the Schematron validation reporting language. Schematron talks about a validation language or a language to express the result of Schematron validation, but this language is not specified in the ISO specification well, it's not specified. It's just mentioned that it exists. And this causes problems for implementers or for people who use Schematron because you don't know what to do. And there are some inconsistencies between the Schematron and the reporting language. This is something that, for example, a future version of Schematron should or must address. There are enhancements like this, maybe it's a simple one, make it possible to provide the type of a variable in Schematron, or maybe a more esoteric one, I don't know. Schematron has the concept of abstract patterns, and you currently, so it's a kind of a templating language for rules, and currently you can't specify which parameters of the template are actually used by the template, which causes problems or could cause problems if you try to instantiate a template language. And if you write a processor, you can't check if the template is used correctly as it should be. This is a quick ride through what we did, what Schematron is. Let me come to the to the future of Schematron. It's worth revisiting the history in short. Schematron was incorporated into ISO in 2006. There was a draft for a second revision in 2010, which was adopted in 2016. So it moved quite slowly. Now forward 4 years, 2020, 3 things happened that are important for Schematron. The first is that a third revision was published that added, among other things, XSL-3 and XPath 3. More importantly, the working group responsible for this specification disbanded. And sadly, ISO made this edition of the standard a non-public standard. Before you could read the standard for free. Now you have to pay money to do this. And this is a problem for Schematron because without a working group, corrections, enhancements go nowhere. If the Schematron standard should change, then it has to happen from inside ISO. And if there's no working group, there won't be any change. And there are things that need to be changed and that people sometimes already did change in the implementations. The four of us discussed about this issue, I mean, the last year, what to do. And our current plan is to initiate work on a new ISO Schematron edition that incorporates corrections, clarifications, and enhancements from the Schematron enhancement proposals repository. A new work item for the ISO SC34 plenary in September will be proposed this month, is the deadline. And if everything goes according to plan, there will be a new edition of ISO Schematron ready in 24 or 36 months, 2 years or 2 or 3 years. Now, what could you do to help? If you are a user of Schematron or interested in Schematron, we ask you to join the discussion of the enhancement proposals. The things we discuss in this GitHub repository will be the inputs to the new work item, which is due this month. So we have to make a selection of what what will be in this work item. If you want to get involved with the ISO process, you can do so through your national body. And if you have any questions that I can't answer now, or come to our users meetup tomorrow at 9:30 and see what Schematron does for other users. Thank you very much.
Thank you, David. We have plenty of time for questions. So, Stephen.
So about the ISO process, how difficult is it to standardize via ISO? And two, doesn't ISO make its money by selling specifications? And so how do you make it available to the wider public?
The first question I can't answer. That's the expertise of Andrew. He's been the editor of the Schematron specification, and he's the one that has the required knowledge about the whole process. So I can't give you an answer about this. The second question about well, yes, ISO makes money with selling the standards. ISO also has a list of publicly available standards that you can get for free. Our hope is that we can change, it will be possible to change ISO's mind with regards to the newest revision that we hope that will be there, that this will be, again, a publicly available standard. I think one thing that's at least clear for me, it's clear is that the lack of an open discussion about the third revision made it easier to close the specification. If we have an open and a public discussion about the things that we want to change, then it might be harder to argue that the ISO has the entire copyright, something along these lines. But well, I don't like to say this. It's crucial to know that even if you have to pay money, it's still an open standard. So it doesn't make it close. A closed standard. It's just you have to pay. I know. but we try to make this an argument to say open standards, and the answer is by certain definitions of open standards, it's still open. So this is not an argument that's passed in the German.
Open but not free.
Yes, yes.
There is a question from Ken.
Yes, I think I can answer a bit of Steve's question as well. I was the Secretariat Manager for SC34 in 2006 when it became a standard. And the PAS process, the publicly available specification process, does allow for a specification that has been developed under a duty, under a process that has been acceptable to ISO as being an open process, to come into the ISO world and be published on that publicly available specification page because it came from outside of ISO. The argument I have heard, now I have not been involved in SC34 for a while, but I did ask, the argument that I have heard is that enough has changed within ISO that the spec is no longer recognizable as the original one that came from the community, and that was their, quote, justification. I don't agree with it, but that was their justification. I'm wondering if the community, by developing the next version of this and contributing that from the community, I'm curious, do you know which national body is bringing this forward?
UK.
The UK is doing it excellent. Maybe there will be some arguments there. I think it will be a tough sell to ISO. And one of the questions that's always been with the ISO version of that is the copyright on the text in the standard itself. You cannot lift sentences out of the ISO document and put them into your software, for example, because of copyright issues. So there are a lot of roadblocks, but at the time, in 2006, we did have the commitment that Schematron would remain open, but I gather ISO thinks that they have changed, the committee has changed it enough that it's no longer the original. I don't agree with that, but that's my understanding of why we are where we are.
Thank you.
Okay, we have one. There is some comment from Andrew. Thank you, Tony. So there is a link to some additional comments from Rick Jellyfy. I cannot click on the link, so maybe interested persons can look into the Twitter. And there is, from Eric, another question.
What I would like to add about the standard is that the standard document that you can buy is actually very short and very terse and very, very technical. So I think if you want to know about Schematron, you don't need it. I mean, don't spend this 158 Swiss francs on this ISO document. Just look at what's online available, and I think there's more than enough information online to be found to learn Schematron.
Okay, thank you. Any more questions? There is from Matt. Patio. A little bit down.
Is there any real benefit to remaining an ISO standard, or could it become Schematroid and step out and be open again if all development is happening in the community anyway?
I think the answer is I'm not a lawyer, but the answer, we are thinking that this is also an option to, well, you would have to write the new text, because the copyright is definitely for the text of the specification, but this would be also a way to move forward to basically fork Schematron at a point in the past and just create your own. Yes, this would be also possible. I think it might make it harder to sell to customers to use this new thing, and you need to write it, so that's...
Stephen has something to say?
So there are a number of XML-based things that need standardizing, and since the XML activity at W3C has gone, we're all all sorts of, we're all a bit orphans.
Mm-hmm.
And it sounds to me like we ought to create an organization to support the standardization of XML-based standards in the community to exactly address these problems.
Mm-hmm.
Yeah, but it's too much work to set up something. If you can just create Git repository. So probably it was all, but if you are interested in Schematron, you can tomorrow morning continue with questions because there will be this Schematron's users meetup. So thank you very much again. So the next speaker will be Tony Graham, and he will tell you something about the differences between CSS and formatting objects.
Pass me your water.
Yeah, sure.
Thank you. Okay. So, am I on? Yes. Thank you. Thank you, Jurka. So, comparison between XSL-FO and CSS. This screw, or this paper, this talk and paper is reduced from a book that Antenna House has produced, which is XSL-FO CSS comparison. The book itself is currently around 150 pages, so I could read maybe 10 pages a minute and you'd understand it all, but I just cut it down to a minimal amount. So I'm going to talk firstly about XSL-FO and CSS and the parts of the comparison, and then in the second half of the talk I'll talk about how I've produced the book. The pages are practically identical for the version that's produced using CSS and the version that's produced with XSL-FO. It's done as an exercise to show that you have comparable results with both of those. So why did we do this? Firstly, it's response to user requests. Some of our users asked, like, what's the difference? Which one should we use? Because AH formatter supports both. So the comparison document, which sort of started out as a list and then turned into a table, you'll find the table in the paper, and then is now turned into this 150-page document. The comparison is useful if you're starting out and you want to explore whether XSL-FO or CSS is useful to you. You can look at the large table of differences and then drill down into the different chapters for specific differences. It could be useful if you're familiar with one, if you know XSL-FO and you want to transition to CSS or using CSS and you wonder why people still use XSL-FO or vice versa. Or if you're like me and you work with both, but sometimes there's differences that might trap trickier. Like the inheritance of the stuff you put in the headers and footers is the property inheritance will be different from XSL-FO to CSS. So it's good to have a reminder of that. So in comparing XSL-FO and CSS, I'm going to look at the history of how we got to where we are, and informal discussion of the viewpoints of people who use the different technologies, and then a very small amount of the feature comparison. So if we go back to 1996, DISL, an ISO standard, which is part of the SGML standards, Ari opened the door to talking about SGML, so I don't feel ashamed, came out. It's the formatting part of SGML. At the same time, CSS1 became a W3C recommendation. CSS1 was built on previous technologies, and it's credited as co-invented by Hakon William Lee and Bert Boss. The goals, as stated for CSS1, include CSS supports stream-based or incremental formatting where possible, and offers both readers and authors control over style. So I don't have a column for XML, but XML became a recommendation in 1998. The XML, as it was conceived, was meant to have three parts: XML, a style language, and a linking language, and XSL became, or the XML style, or whatever it was, became XSL, Extensible Style Sheet Language, which initially contained a transformation part plus a formatting part, because DISL before it had also contained transformation plus formatting, though in practice we mostly used the formatting part, and even the formatting engine that we all used developed a transformation part that worked like it was formatting. Along the way, XSLT was seen to be broadly useful, and it became its own family of standards. And what you find in the XSL recommendation is a short chapter that says go and look at XSLT for the transformation part, which conceptually, to the XSL recommendation, is still part of XSL. Along the same timeline, CSS2 became a recommendation in 1998. So we have two things developing, not really in parallel, as in almost in antagonism, but there's a tag finding from the W3C Technical Architecture Group which said that consistency of properties is part of the fundamental architecture of the web. So you'll find that CSS and XSL-FO, for the properties that were defined when they were both still being worked on, if you have the same concept, you use the same property name and the same property values for them. So a border is a border, whether it's in CSS or in XSL-FO. XSL 1.1 became a recommendation in 2006. After that, there was a workshop in Heidelberg, which was attached to a W3C print symposium sort of thing. At that workshop, people talked about what we want in the next version of XSL-FO, and Tanner House proposed that there be more cooperation between CSS and XSL-FO, but that was sort of voted down by the participants at the workshop. XSL-FO continued with a sort of reduced working group and eventually petered out before producing an XSL 2.0. CSS was modularized so that people could work at different parts, at different speeds, rather than having to get everything cooked all at once to make a single recommendation. And in recent years, CSS has produced what they call snapshots, which describes the current state of the different modules, the ones that are stable, the ones that are still experimental. The CSS page media part of this, as we've heard yesterday from Andreas is sort of found and it doesn't get much attention, doesn't get much love. And in fact, some of the properties for page media which were defined in working drafts, I don't know, 5, 10 years ago, have since been dropped from more recent working drafts as not applicable. It's hard to go back and find out what the properties were at different points in time. So I've used the properties implemented by AH formatter as a bit of a proxy. If you look, this purplish bar is the properties it implements that are both defined in XSL-FO for XSL-FO and CSS too. And these ones are the CSS 3 properties that are equivalent to properties that are already defined in XSL-FO. In contrast, the properties that are applicable just to CSS for page media, as far as implemented by AH formatter, are much smaller than the common properties. So this is an informal summary of how a person using one technology might think about the other technology. It's informal, no scientific research behind it whatsoever. So a gripe for a CSS person might be that you need to transform your markup, which of course most CSS users would think has to be HTML, into something else before you can use it. Well, that's very true, but as we saw yesterday, you quite often need to transform your source into something else before you can print it with CSS, because you need to generate or update the table of contents. You need to generate the index. For CSS, you need to generate content in the flow that will be taken out as a running element to be used in the headers and footers. So somewhere along the way, there has to be a transformation. You'd hope, I would hope there's a transformation to improve the appearance and the information content of your formatted printed document. The use of separate attributes for XSL-FO is verbose when you have properties and the properties can cascade, etc. But if you come from XSLT, then being able to work with attributes and generate individual attributes is just like natural. You could use JavaScript instead of XSLT to do the transformation part if you do the transformation. Well, that's very true, but I haven't seen a standard JavaScript architecture for doing transformation the way that we just naturally use XSLT to turn markup into markup, in this case into XSL-FO markup, if you're using XSL-FO. So the FOs are like elements with a fixed display property. This display property in CSS says this element should be formatted like this. It's sometimes used to make lists look like tables in an HTML page, but if you have the transformation before formatting, then the decisions about how this element should end up are done in the transformation. You don't need to change it on the fly when you're formatting. XSL-FO can't be used for web and print. That is for the most part true, although Ken Holman demonstrated or talked about something yesterday where he generates EPUB from his XSL-FO, although that is not widely used.
There's a complaint from people watching this live.
I'm not surprised. Okay. I shall talk louder. Is that better? So CSS is easier to use than XSL-FO. In a sense, yes. In a sense, no. I mean, the structure of CSS as a selector, a body with properties, which is property name and then a definition, is conceptually simple, but there's an exploding amount of CSS properties, many of which have their own micro syntax. The charter for the CSS working group from 2004 described CSS as a large and complex language. They've been adding properties since then, but their more recent charters just say that it's a large language. Somehow they've mastered the complexity without reducing anything. And there are more CSS users than XSL-FO users, which is very true, but of those, there's a small core that at this point understand CSS for page media. We, of course, would like for there to be more people using CSS for page media. Sort of informal view from an XSL-FO about CSS is that CSS just decorates the tree, which is very true, but it's part of the initial goals for being streamable and just working with the document. CSS selectors won't look down or forward. We heard this yesterday in a question from someone at one of the page media meetings yesterday. Again, this is part of the design goals of CSS and the design goals of the browsers to do things quickly. There was many years ago, there was resistance when Jurka tried to get CSS selectors to even look into the attributes, and part of the rationale for why they accepted his proposal for possibly a short time is that it would help get rid of XPath if they could select on attributes. Because CSS only operates on elements, again from the discussion about Jurka's proposal for attributes, it's clear that people who think in terms of CSS think only in terms of elements, but if you're using XSLT, then you quite possibly match on the text content of an element, or you quite possibly match on the text content by looking up a key from somewhere else or some other document to work out what to do. The feature comparison document has these chapters in it. I'm really not going to go through them all right now in my remaining 11 minutes. I'm just going to talk about the first three very quickly. The first one, box layout. If you just think about both CSS and XSL-FO as being made up of boxes, they're all made up of rectangular boxes at this point, then you've covered 90% of your uses for CSS. Boxes can have content around that. You can have padding to separate the content from the border, and then there's properties for margins. CSS and XSL-FO have common properties for all of these. XSL-FO will map some of the margin properties to more direction-specific properties, because it initially paid more attention to the directionality of text than CSS did at the time. But they have the same concept of a box has padding, margin, and border. In page layout, because this is all about page media, in XSL-FO you make a simple page master which can have these 5 regions, the region body and then the 4 outer regions, and then you can direct content into those, and they're not further subdivided unless you pour content into them that perhaps has a table or something in them. CSS defines a page area, and then the area around it is the margin area, and as we'll see, that's divided into 16 page margin boxes. So as I sort of said, in XSL-FO, you generate static content and you direct it to different named the page outer regions with the different names. So we have one here for the even header. This static content is only used on the headers of even pages, and for this one here is called first outside. The only page master that has a region name like that is the first one. So we have something different on the opening page of our chapter. So the FO concept is pouring static content into named regions, which might or might not be on a particular page. The CSS concept is, as I said, you have these page margin boxes, and they have particular names, and you can direct content to those in your either as the string value of an element that is still in appears in the flow of your document, or you can generate content for it, or you can declare an element as a running element and it's taken out of the flow and used in one of these page margin boxes. It's essentially, it's equivalent for FO, you generate content in a static content to be used in the outer regions, but for CSS, the content is still part of the flow, but it serves a similar function. So the second part in the remaining time, if I'm lucky, is to talk about how we produce this book, this XSL-FO CSS comparison, which is available formatted from XSL-FO and formatted from CSS. And the pages that are produced are so identical, you really need the antenna house regression testing system to find the differences between the pages. For the most part, line endings are the same, so obviously the pages break on the same words, etc. How this is produced is the CSS version, HTML, as I've said, it's augmented to update the table of contents, create the sidebars, the text for the sidebars, actually the offset for the sidebars, and then it's formatted, the CSS format using CSS style sheets. And you'll see the XSLT version takes the same augmented HTML to produce XSL-FO, which is then formatted with the XSL formatter. Oops, I didn't blind anybody. So you see, I've said most of this already, that the authoring HTML is augmented for table of contents, etc., that you really don't want to have to maintain by hand in the authoring document. And there's syntax highlighting the code samples, which you really don't want to have to maintain by hand. The CSS styles are based on the same styles that we used for the introduction to CSS for page media, and just it was done in the interest of time and for consistency to just reuse the same styles. The FO, the XSLT that generates the FO starts, as I said, from the augmented HTML, and it re-implements the CSS styles. It's just, the part that I wrote for this was just the stuff from the CSS styles for the book. I didn't have to rewrite, write a complete transformation from HTML to FO because there was already one on the Antenna House website. But I did update parts of it to run as XSLT3 rather than XSLT1. The HTML to FO style sheet, the XSLT1 version is still on the Antenna House website. Since it's in XSLT 1.0, it makes a lot of use of XSL attribute set, which has its uses because you can have a named attribute set and add to it from different modules to build up or override properties. Another feature of attribute sets, which doesn't get used very often, I don't think, is that attributes are evaluated every time you use them. So the party trick is to generate an ID that is different every time you reference the attribute set. Of course, the problem with attribute sets is that while you can add attributes to an attribute set, you can't take any away, which contrasts that with CSS, where you might have a style for an element like table, and you might have a different class of table that has additional properties defined for it, and those properties are applicable there. If you added border color and border style to an attribute set, then they'd remain with that attribute set for the entire processing. And I didn't really want to maintain separate attribute sets for every possible context. So I did a variation on something I presented, if you have a history for trivia, back in 2014 about comparing maps with using attribute sets. This time around, I'm declaring a table of local properties as a map, which I'm declaring everything to the table in one place. In the real code, there's multiple entries in this outer map, and I declare the properties and their values. This obviously is a string, but that could itself be an expression, or it could be a function that calculates something more complicated. Might be a function you provide an XPath to go off and find something else. You might have also seen that there's a parameter which could be overriding properties that would override the properties in this one. So the next step is to merge the ones I inherited, potentially, whatever they are, and to take priority over the ones that are declared here, and then to use next match to find the next less specific template for these standard tables and provide my set of properties to it, and it would use my set of properties to override whatever else it would declare. And how this would be used, again, cut down from the code, is the table properties are passed here, and it's just the function that picks out the properties of interest and adds them to what you can't see. There's a table element created there. So in this way, I was able to replicate, for the most part, well, I was able to replicate how a class adds extra properties in a specific circumstance. So possible future work for this would be to further expand the comparison document. It's a bit like a fractal. You look at it and you see the detail, and then you drill down, there's more detail that you can see. I mean, there is a limit to how much detail anybody wants to go into about the differences and commonalities, but if you go and look at the book, you will find that the later chapters are getting shorter as time ran out and I ran out of energy. So Antenna House doesn't actually need a universal CSS to XSL-FO translation tool because we have a CSS formatter, but I've been using Transpect and CSSA for something else, and it has occurred to me that you could perhaps use that to use the CSS tools. It makes attributes for all of the CSS, all the properties in your CSS. It resolves the priorities, and then you can process that with XSLT as you like. So the comparison, we're saying that there are these common core properties which follow from the tag decision, the architectural principle for the web, that where possible properties should be in common. There are some obvious differences. I've shown you how the pages are made and how content is directed to the headers and footers. And there's many minor differences. If you want to know more, read the book. AH Formatter smooths out many of the differences because a lot is implemented for the other. And as you saw, it's possible to produce output which is functionally identical using either XSL-FO or CSS. You could make a general transformation that does this. I mean, Oxygen has a product which will do this. But as I said, I don't particularly need to do it to solve my need. So there's the URL, and thank you for your time.
Thank you very much, Tony. And we have time for questions. So, from Ken, yeah.
Thank you, Tony. I just wanted to augment your list of available resources, something I meant to mention yesterday, but I ran way over time, thanks to the patience of the organizers. But 5 years ago, I made my FO book and my XSLT book freely downloadable from my website instead of selling it anymore. So if anyone's looking for a tutorial approach to learning more about FO, just go to cranesoftrights.com. On the right-hand side, it says free books. And you can go to the free books and download any one of the books that I used to sell. So,
thank you. So do we have more questions? So it seems that everybody is willing to have another coffee. So thank you very much again.
All right, thank you.
And we will meet there 5 minutes after 4 o'clock, so enjoy your coffee break. generation.
Okay, so I hope this works. You can hear me. My official name is Vít Janota, but I'm Vítek, and I'm not. Sorry? I don't know. Oh, I don't think so.
Or we can just try the second one.
Okay. It's the same. I don't know. Is it better? Yes. Okay. I will speak more loudly. Okay. Okay. So, I'm obviously not only the proud organizer of this conference almost from its very beginning, but also I'm a developer. And for past 20 years, I worked in different projects and companies, mostly concerning somehow XSL and XML, and also web front-end and back-end development, just to give a brief overview of my areas of interest. And for past 2 years, I've been working for V8 company, and it brought me quite new experiences in the area I haven't worked for before. And and I would like to just share with you and cost prohibitive. V8 automates this creation of software videos, making it fast and easy to produce up-to-date content anytime it is needed. So this business talk basically means that it's really hard to produce software videos, and then we are doing our best to make it easy. Okay, so what I would briefly define what we mean by software videos. These are those, let's say, documentation or tutorial or educational videos when you simply show how to accomplish your task or some task in your environment system in your software. So simply from adding a user up to configuring virtual server or whatever you can imagine. And why it's hard to do? Well, producing of 1 minute of video on the professional level takes on average 4 hours of work. That's some survey of Adobe, and also it's confirmed by the people who ask us for help or who are our customers. There are not only technical issues, I mean that you really have to physically perform the task you want to show, like clicking into your software, scrolling and moving mouse and so on, and record all this. But you also have to record your audio, and your voice should sound somewhat enthusiastic, but not too much. There should be no background noises like dogs barking or police siren howling or your wife asking where you gonna come for lunch and so on. And if you succeed in all this and you record it successfully, then there is a post-processing because you want your video to look fancy, so you would like to put some animated logo of your company at the beginning or at the end, which we call bumper videos, or you can have closed captioning, subtitles, some effects like highlighting, callouts, whatever. So, and if you succeed, if you successfully pass this really hard and painful way, then your software company comes with update, and UX guys say that it would be really nice to move the main menu to the right and not call it a main menu, but things you can select from, and you're done. You have to start anew or somehow edit what you already done, which is quite hard, editing videos and changing things in it. And this multiplies when you use localized versions. I mean, different language areas, different languages. And it's the problem of scale, because we are not talking about a few videos, but about tens to hundreds of videos, which our customers usually have. So, and the scale is such a big problem with all this that most companies simply resign to use videos as a documentation to begin with, or simply especially when it goes for localizations. So that's our motivation, and we are looking for the way how to automatically generate these videos easily and maintainable and changeable way. So how we imagine that? This is our ideal workflow. So here we start here in this part, and we simply take any existing documents the company already has, which we can use, I mean, or documentation, tutorials, or whatever, and we upload them to our system, and then we digest them. It's if you want, it's some ETL process where we simply extract information which is vital for us or usable for video generating. Then we store it here in some internal format, which I will talk about in a bit. And once this is done, we pass this internal document to our rendering engine, and this rendering engine connects to the environment in question and simply starts to read that internal document and perform these tasks which are described there, which is this one. And once it successfully happens, you simply render this activity, then you store the final video, you post it to the world, your customers are happy, you have more money, and we probably, hopefully, will have more work to do for a couple more years. So let's look at this process in detail, and I will start with this part because it's mostly my home where I live. So I start with the internal format we use to store the video information for further rendering. We call it Spiel XML with an S-P-I-E-L with the German pronunciation, and surprisingly it's XML. Why XML? I should say use markup stupid, but the reasons for that were that it turned out that most of our customers somehow use XML one way or another. Either it's purely XML like DITA, XHTML, or some proprietary XML, or they use XML-based formats like docx or Google Docs or whatever. So it was a logical decision to use XML, and the second thing is that technical precision of XML, because we are using not only the content, but a lot of metadata around, and we really need to be precise. Sorry. Yeah, we tried some loose formats like Markdown, but I wouldn't say that it was a disaster, but it simply did not work. So we use XML. This XML is fairly simple because it follows the logic of the video or the storyboard. So it's a linear format where simply there are a sequence of spoken blocks and actions to be performed. So say this and do this, like the video goes. So if I show you a very simple example of XML, of our Spiel XML, you can see that I was cheating a bit, I was not precise a bit. It is, in a sense, a linear sequence, but there are some exceptions. These speak blocks, which we call PI paragraphs, are in fact only wrappers, and we use elements from different namespace, SSML, which is speech synthesis markup language, which is a project for text to speech, because if we generate this video automatically, we also need to generate the audio automatically, and we want to use the full power of this project or this protocol. As you can see down here, for example, the first task was to learn the English voices, the proper German pronunciation of Spiel, not to say Spiel, but Spiel. And the second thing where I was not that precise is that we allow our elements inside of SSML speak. So it's not entirely linear, but almost. And so typically these are our commands, mostly void tags, even if you've got a few per tags like title or, for example, slide, if you want to put slide in the middle of your video. And the format is pretty simple. The name of the element defines the action, and there is a bunch of attributes which are simply parameterize what should be done. So obviously, this should click somewhere, and where that's defined by the selector, which is either XPath or CSS selector, or simply simplified textual selector, which looks for the first occurrence of the string in the page you are working with. So this is it, and We, of course, got a schema for this, which imports the SSML schema and extends the imported schema to allow our tags within the SSML speak elements. So we can really validate that what you've seen in the previous step. And yeah, so schema is pretty simple. There's not much to it. So this is just an example. The click element is defined. And you can see that except of selector, it also allows modifier if you want to perform alt-click, shift-click, or control-click for whatever reason. Or you can, instead of selector, use precise coordinates, where to move your mouse and where to click. So, and in fact, schema is for the central thing for two reasons. No, our element can be used in Spiel or can be digested into Spiel under as defined schema, so we validate any upload process and simply ignore all invalid elements, and we also guard that there are proper attributes, and required attributes have values, and we emit some warnings and so on just before the rendering process begins. So it's easy to to speed up the process simply. And on the opposite side, the rendering engine functionality is strongly related to schema, which I will also show in a bit. So this moves us to the two parts of the pipeline, which is before the Spiel XML and after. So ingest process and the rendering engine. So regarding why do we ingest already existing documents, why don't we simply have an editor? It's, I would say, purely business or philosophical decision. We simply do not force to use people to change their editors or their habits or format they use. And yeah, they can work what they already got. And more to it, we would like to bring the V8 functionality to the environment they work with. So we are working on Google Doc plugin and Oxygen plugin, which is quite interesting. And it should work the way that simply if you edit some data document in the Oxygen, there is a button. When you click it, it opens the preview window and start to show you the video, which is based on the document. And if the guys from Oxygen are interested in this, we are interested in to talk to them. Okay, so that's it. So if I take some very simple data document, you can see that there is obviously that what can be used as a audio for the video you want to show, but where are these actions? They are not there, obviously, and we tried some automatized ways how to guess what to do. For example, you got click, video, link, so it's obvious that they want to click something, and if you analyze the page you're working with and find something which is called videos, it's possible that you won't click that one. In theory, this worked. In reality, that did not work because the human language is so loose that it was simply impossible to somehow manage it. And yeah, there are 10 ways how to say that you want to select something. And if you cover all these, you find 11th one in the next document. So, and our customers tended to say, but I want to click directly here. So we decided to allow the explicit annotation of these documents. But it turned out that to mix this XML with our markup, even in different namespace, simply won't work, because mostly these documents were already designed or to be used in different, like for printed or online purposes, and the engines mostly are confused when they see different namespaces and so on. So we were looking for an unobtrusive annotation of existing client documents, and obviously the easiest way are XML comments or processing instructions or Word comments or whatever. So we minimize these interactions I was talking about. So how does the document look like after we annotate it? It looks like this. Processing instructions are ideal because they are not only syntactically, but let's say also semantically correct, and we can use our own processing instructions, which are easy to filter. And simply value of these are our markup. So it's fairly easy, a bit challenge for the ingester because it has to simply parse all this what's inside. And when I was talking about pair tags, we also allow that you put opening element in one processing instruction and closing somewhere else, which means that we have to also restore the tree to create a valid XML. And it's obvious why we need schema, because people can put anything there, and we simply have to validate it and tell them that they are wrong or that made something wrong, that they mistyped something or whatever. So that's, and anything which is not defined schema is simply ignored. So this is it. Yeah, for people who don't have any documents, we also offer something easier than to write directly XML. And it's a simplified storyboard format written in docx or Google Docs, which somehow follows that what's in Spiel. So it looks basically like a table. In the first column, you've got a narrative, and the second column, you've got those actions to perform, and so simply reference them. Why to reference them? Because you can have something like this, and it means that you have multiple narrative columns and you fill only one, and that's the plugin we are working on. It already works, and when you simply put into second column the language code and you click on it, the Google Translator translates it, and you can have as multiple columns with languages as you want, and you simply reference these actions, which is passed correctly, and you can then have this as a base for the true translation or just to correct it, and you can generate from this one document like three XMLs in different languages, so you can, it's a single source for multiple localized videos. Okay, so this is it regarding image formats, and now the true heart of the system, which is our rendering engine, which takes this Spiel XML and turns it into the videos. So it's a browser automation similar to browser-based testing, but of course it extends or changes the functionality because we need feature specific for video production. That's the one thing. And second thing, that on contrary to just browser-based testing, not only the result is important, but also the entire process, because it has to be visual, because we are recording it, and so it has to mimic the human behavior, because our ultimate goal is to pass Turing test. So it means if you've got several minutes video to generate it, that it looks as it was made by a human being. So we have to mimic our gestures, or mouse moves, clicking, and also we also supply sounds for clicking and so on, for typing and so on. So this all does the engine. From the point of view of interpretation of Spiel, it's also interesting because basically each our Spiel element acts like a command for our engine. So it means that each element simply defines a function call, the name of the element defines which function to call, and the attributes are simply parameters for that function call. So you can in general terms, think about Spiel XML as an assembly language which is compiled by the engine into the final video. Yeah, just few closing remarks for this. Really, the engine rules everything. It means that when the commands are properly run and everything, we get the videos with everything, with clicking, typing, callouts, effects. And if something is missing, then we simply define it. It's the workflow that you define the feature in the engine, and when it's defined in the engine, we shape how the XML element should look like. We put the definition into schema, and from that very moment, when you digest any document and put that element there, if it's in schema, it appears in the spiel and the engine can interpret it. So this was, for example, an example of those bumper videos. It turned out that people want tiny videos at the beginning, at the end, to show something, and so we simply, they upload these videos into our system, and we've got a video tag where you specify, simply reference this asset, and it automatically put it there, and the engine waits until the video is done and then starts with another action. So the proper timing is the key thing, and yeah, and that's the true trick, that we know how to do it properly, that it looks, that is smooth, and that no post-production is required. Okay, demos, yeah, that's from our internal thing. I think I would not show you the live system because I would be teasing the demo gods too much. So I'll show you, just to give you the feeling, the sample from with the permission of our clients, how the result looks like. So hopefully it will work also with sound. I don't know. Yeah. So it's a bit commercial. Sorry for that. And here.
In this task, you log into Workspace 1 UEM console and set up a PIN. Open Chrome and log into the Workspace 1 UEM console URL assigned to you. Type your username. System, security, restricted actions.
So no human being touched that, and no animal was harmed during this process. So.
If you create a role with Create Role privilege, this role is visible to all the users in error. From the dashboard drop-down, select Administration. Go to Access Control, select Roles, and click Create.
And the true beauty of this is that you can wait until something loads and then you continue recording, so there are no delays like when you're waiting, and so on. So.
Description. Type a description for the role. Select the privileges that you want to assign to the role.
Yeah.
Click the right arrow button to add the selected privileges to the role. Click Create. From the Roles page that appears, select the new role from the list to view the details.
Yeah, the last one is showing the highlights, which are the red boxes around the elements. Ecumenica company wanted everything to be highlighted when they use it. So.
While you are still on the journal transactions form with the needed batch listed, click the link in the batch number column to open the batch.
Yeah, that's it. So it's automatically done during the process.
On the menu,
so.
under corrections, click reverse.
Simply by highlight command.
The system generates and opens a reversing batch. In the summary area, notice that the number of the original batch is shown in the original batch number box. The reversing entry checkbox is selected, and the batch's status is on hold.
Yeah.
On the form toolbar, click remove hold.
So okay, I think.
On the form.
I can no.
Form toolbar, click release to release the batch.
Yeah, hopefully we're done. So basically, how this solves the problem I stated at the beginning is obvious. Once you succeed in properly annotate your document, so it renders the video, when something changes in your system, you simply adjust the input document, you re-upload it, and the video should be retaken practically in the real time, what it takes when it plays. And when there are more changes, you simply have to adjust more in the document, but still it's the faster, and how to solve the localization I've shown already. So that's all from the V-Day project, and sorry. I don't want this one. Okay. because this was the last one. Thank you.
Thank you very much. It looks quite impressive. So, any questions? From John?
I thought that was very cool, thank you. Less of a question, just more of a wish list item. I wonder if you could, integrate that with deepfake technology so that I could have Michael K, commentate all my videos.
Okay.
Any more questions, comments, or suggestions? Yeah.
Yeah, I really enjoyed the this presentation as well. Just wondering how, I guess it's designed for tutorials and things like that.
Yeah.
Does it work with sort of real motion videos, and how, like if you're filming?
No, this is at the moment it's purely tutorial documentation. It's like when you're clicking in your software. Yeah.
But I mean, like things like where you have to overlay things on the screen. I mean, I don't know.
Yeah, there are some transition effects and things like that, and we even are able to log into some console and do some command line things and so on. So, and we are still extending. So whenever some feature or some requirement comes from other customers, we are looking for the way how to incorporate into it. So it's an open process. Yeah. But
interesting.
Okay. Another question here.
Personally, I hate videos because when you look for an answer using Google, you find a good video and I skip it because I just want a quick answer by reading. But maybe you could have the text also searchable by Google so that I find the information and maybe I can read then the text.
Yeah.
And then later I may decide to watch the video.
Yeah, that's actually I think that we are in the state of POC. There's annotating the video, like when it's playing, you can stop it and type some annotation into it. But yeah, that's also the idea. So there can be some workflow for editors, for reviewers, and so on. So yeah, there are a lot of possibilities still. Yeah.
So anyone else? Okay, so it seems that you're out of questions. Thank you very much again.
Yeah.
And unfortunately, Kirsten has to change plans last minute, so she can be here in person, but if everything works well, she will be able to give her talk remotely. So just give us a minute to set up and connect everything.
Thank you very much. I'll share my slides. You should see them now.
We can see the slides. And we can see you as well.
Okay, cool. So thanks for making this fun. I can join you online. I'm currently with my brothers and I'm not able to travel. The title of the talk is Structure, looking at more than you see, and this originates from one observation or awareness blog. And the title actually comes from a conversation at one of the last coffee breaks. Someone, I think, with Stephen Pemberton, when we agreed that I first should submit something, it should be about structure, and we agreed on the title to be structure exclamation mark, and then look for what to actually do with it. So I identify myself as maybe a document engineer and a writing researcher, and I will talk about natural language text documents and the tools involved and the practices involved. So I'm interested in writing technology. I will not show any angle brackets also, but talk about technology and how to use it and what to use it for, and then trends might go. So it's about tools, word processors and editors, and practices, word processing and editing, and then the document finally produced, how to distribute, display it, use it, etc. So for a brief look back, when we first talk about creating a document, and I speak about natural language text documents, we have the editors in the 1960s coming from the need for programmers. So the development comes from universities and companies to allow programmers to code and also to write text, and then the observation came that code actually is text, or text is actually code. So but you have these big machines and you have a keyboard somehow, and you will write. And then in the 1970s, computers actually got integrated into offices, so the machines became much smaller. And this development was initiated by IBM, who then at that time conquered the office and offered support for spreadsheet calculation. That was the main task then, and also then document creation. And from that time, we have terms and concepts like office automation, word processor, and word processing. And also, actually, since the 1970s, we are straightforward to the paperless office. So at that time, the word processor is a physical machine, not the program, but the physical machine. And the first developments of software for smaller things than the big mainframes. So developments for microcomputers, these were programs like electric pencil. That's one of those. And the term word processor and word processing actually is owned by IBM. It's a concept from roughly 1955 by the German IBM typewriter sales executive, who had the idea that when you can process data, then you can of course also
We can't hear you. Yeah, I can see that. This is the reason why we prefer in-person conferences. So, okay, I will try to reconnect as well. Okay. Yeah, so you dropped for a moment, but you are now back online. So.
Okay, and I'm concluding with with your camera.
Yeah.
Okay. I think
you should start sharing your screen as well, because we don't see your slides now.
So
Perfect.
this should be up again.
Yeah, everything is great. So please continue.
So the red comes from the operation that you have either the text or data or text and data and process it and write it, put it and think about it and produce documents. And he proposed the concept of word processing in analogy to data processing. And but this went into advertisement and actually being used by IBM only in 1970, at the time when they replaced the electric typewriter division by the office products division, and then they actually had word processing. So I skipped this advertisement word here. The idea was to turn writing into something comparable in terms of automation or mechanization, like the automobile branch with assembly lines. That's a weird concept, but in the 1970s were weird times. And then in the 80s, you probably recognize the two screenshots from the two worlds of personal computers. One were text-based at that time, that's MS-DOS, the right one, and the left one is Apple, and that's a screenshot of Macworld for Apple. And if you look at the screen or the design, then the form or the visual of this application window is still very similar to what we have today in all kinds of writing tools on applications. So in the 80s, writing tools, word processors became wider than the PC to the general public. And also at that time, we can observe two developments. One is that a movement from having explicit expert and expertise and explicit firms who did publishing to the desktop publishing and allowing this for almost everybody to be your own publisher, to be your own typesetter, to be your own layout. And we have these desktop publishing programs, PageMaker, QuadExpress, FrameMaker. Some are still around, but most of them not. And the other concept from this time is VisiBig. What you see is what you get. And this came from the need or user demands that when you write a document or write a text, you would like to see how it looks like as a final document, and the final document was most of the time the printed page. So you wanted to see how this would look like on the printed page in either A4 or letter form. And it's of course much too costly to print every intermediate draft and have a look if this is now better or if it fits on one page, etc. So there was a demand to have this view, this final or this target view on your screen, and also be able to edit in this view. And this is what you see is what you get, and what you get would always refer to the printed page or a printable page, so for a PDF. And we also have this concept of what you see is what you get later in editors intended for web pages, where of course the intended final product or final document is not a printed page but a web page, but also for rather fixed dimensions and for the screen. And also this is not the VisiBig for web pages is not such demanded today. In the 1990s, we can also observe a certain process of standardization. So this screenshot is from Microsoft Word at the time where they had the buttons in a 3D shape, so you can easily see which of the buttons have been pushed, which are available at all, and you have this VisiBig screen. In the 1990s, Microsoft Word became the de facto standard, and for two lines, one for the user interface. So later on, when we see content management systems and especially learning management systems in the early 2000s, and any place where you would integrate an editor and offer people to edit something, when you were the developer to implement such an editor into another system, then the very first demand and requirement from users was, please make it that it looks like and feels like Microsoft Word, so users will be comfortable using it. So we have this de facto standard for the user interface, and we also have a de facto standard for the file format. And the talk before by Bit also said that the supported format is docx and Google Docs. So the Microsoft Word standard file format still is a de facto standard. And at that time, Word Project disappeared mostly due to marketing reasons. We also then see other developments to have free and open software, but also these developments and also Google Docs, when they started, one aim was for the user interface to make it look like the standard, to make it look like Microsoft Word. It just was this way. And all of them were WYSIWYG, so what you see is what you get. You would edit in a view that resembled the page or pages that you would be able to then print. Most of you, I think, also remember these times where Microsoft Word actually listened to users and added functionalities and menus, etc. Which resulted, and that's my focus here, which resulted in the place or the space actually available for writing the text as a writer became smaller and smaller. Everything was occupied by menu bars. In the 2000s, when the web appeared and the internet and open source programs, then Google Docs had been developed originally by a small program from a few developers. Then they bought additional programs, and one main feature was that the export was possible in Microsoft Word format. And the same goes for LibreOffice, so there's a whole interesting buying and releasing story behind LibreOffice, which started out as StarOffice. And also LibreOffice is able, of course, to export files in Microsoft Word format. Why is this? Because most of the actors who receive these documents, publishing houses, when you submit something as a student somewhere or for a conference or for a journal, one required or even demanded format is please submit in Microsoft Word format. So you have to be able to produce something in Microsoft Word format. For these two, you were able to produce Microsoft Word and Microsoft Word format file, but not using Microsoft Word. And then came the 2010s with even more applications in the cloud, on the internet. Google Docs became an established collaborative tool, always accessible. Microsoft tried to keep the pace, is in the cloud rather late and of course not free. But the main important point here is that this, even as already in the 2010s, we can observe the appearance of so-called non-destructive editors. And the one I'm showing on the right is IA Writer, which is around, I think, since 2011 or 10. It's advertised as non-destructive and focusing, letting the writer focus only on the text. So everything is either non-existent or it is possible to move it into the background. So you have your actual application window is only the place where you write. And this trend becomes stronger in the 2020s. You can summarize it as, I don't care about tools, just let me write, and of course vis-a-vis does not matter. And one reason is that people have, so we see new tools or applications allowing people to input text, put it this way, and manipulate text from notes to more elaborate documents. And if there's a need to submit this or to forward this document, this text to somewhere else or someone else in a certain format, then we today have very comfortable either an export function or programs like Pandoc allowing to format the original file or the original format of my application into the desired format for submission. So I actually am no longer forced to use Microsoft Word or Google Docs to produce a Microsoft Word document file in the end. And what we also see, and this is growing stronger, that the editors have optimized versions for computers, either desktop or laptop or smartphone or tablet. I'm not sure about smart watches, but maybe this is also possible for different operation systems, etc. So, and as of course everything is living in the cloud, you are able to write and edit and revise a document from any interface you have, or all the way down. And what we see also, and what supports this development, is new or better input options. Dictation is becoming better and better. Scanning and OCR is becoming better and better. We have virtual keyboards with funny arrangements for one-handed use or two-thumb use or one-thumb use, etc. So it's possible for me as a writer to find the best suitable application to write text. So what's about the documents? I have to display or distribute not the text, but the document somehow. But then we have for electronic or online documents, we have of course responsive design. So your document adapts to the size and the resolution of your screen. When you look at academic publishing, journals tend to publish, of course, online first and maybe online only. So there is you are not requested to please have your graphics or graphs or plots in a certain size or format. It is just, it's there and it's zoomable, or it's displayed as such, so there's automatic fitting of these non-textual media. And what's also important, there is not only one single target format for your text. So you write text, but it's a bit like single source publishing. It might be printed on various formats. It might be visible on large screen, small screens, with integrated graphs or videos, etc. So that's all possible. And I, as a writer, I don't have to care about what it's done. I have to write, and maybe, so that's, I write on my iPad, maybe I want to see in the immediate step how this would look like in a default rendering, and I'm able to do this. And this is the view on the left, with syntax highlighting turned on for adjectives, verbs, and conjunctions, and on the right it's the portrait mode with the virtual keyboard, and the focus is on one sentence. So I only see the text, and with only markdown declaration. That's the same text on my laptop, and then I write, and in the end I have a makefile, and can render it into any desired format. And if I have someone who's taking care of my XSL file, then of course all the web items look like they should look. So, but that's not the problem of writing the text. That's processing or post-processing. I take care of this later. And what I think, what we see with the possibilities or the easiness to implement writing applications, there is again, or at least a separation of content and form. So as a writer, I'm not so much concerned with the document structure, but with the text structure. So the writing technology allows me to write text. Of course, I have a structure that I have paragraphs, I have headings, subheadings, sections, I have references, I have images, but during writing, I'm not caring that much about the final document or one of the possible final documents. I'm able to render and distribute this text as a document in various formats using various tools, or giving this just someone else, somewhere else, and then it's taken care of for me. And with this separation between document and text, I'm also able to allow for yet unknown document formats, which I'm not aware of and someone else might come up with. And from the document engineering point of view, that's the observation, there is no one single target document format for writers. There's of course dynamic rendering possible and necessary, and I can split these two tasks. I can allow for some default rendering, default size, default font, default color, etc., to give the writer the opportunity to have a look how it might look. But that's not the one and only single final document to distribute. So one conclusion would be that during writing, and for writers, human writers, the document structure becomes less important than text structure. That would be my claim, and the applications we have allow for this view. In a visual format that, of course, we have structure in a document, the final document has structure, and someone has to implement and come up with a solution for how to render and how to produce this document structure. But for me as a writer, that's not the important point. I care about the text structure. That would be on the right side. I work with this text, and then I care for the document, or I get feedback on the document. I order a different document, but the text, I'm working with the text. That would be my contribution to XML Prague, to the view for writers and writing technology, allowing to writers to focus on content and being sure that something nice will be produced by someone else or something else.
Thank you very much, Kerstin. Have you heard applause from the auditorium? Oh, that's cool, because I'm not sure how much you hear from us. So we still have time for questions. Okay, so it seems that, so Ken first, and then Stephen.
I don't quite know how to ask my question, which is why I was hesitating until no one else raised their hand. And that is, you've been given a task to write. Don't you have in your mind's eye a structure that you want to follow? Or where do things begin? You've been given a task to write. It's not just a bunch of paragraphs, is it?
No, I have, that's true. I have structure, I have the idea of sections and subsections, but if this in the document is blue and the size is that's not my concern.
Okay, so you have in mind a structure. Now you have a blank page in front of you, and you want to focus on the writing. By entering a short line of text and then beginning a new paragraph, does that imply that's a section heading? because I'm going to be responsible for taking your text and making a document out of it. So I don't know what I'm going to do with. I want to support you as a writer, but I don't know what I'm going to get from you.
I try to share my screen differently. So you should see now my that's actually how I write. I mean that's Markdown.
Oh, you are using Markdown. Okay, I missed that. Okay.
So I have this structure roughly, and I have a period button, which renders a default. It's a default font, default size, and the sections are numbered. So I can see, but I have no, as you can see, I have no page breaks.
Oh, yeah, no, that's fine. I think you've answered, I guess I skipped over the markdown that is, are the clues that I'm going to use, to give you your...
Otherwise than this, I would, I mean, and that's also a habit I have anyway to split paragraphs by...
Oh, yeah,
by a blank line.
Well, and thank you for the nostalgia part of your presentation.
So that's minimal declaration, but that's very, very simple markdown and reference in this way, and then somehow this will be resolved, but my makefile is controlling this.
Okay, thanks. There is another question from Stephen.
So I was kind of shocked when I saw the bit where you said WYSIWYG doesn't matter anymore, because I'm aware of research that examined the difference in the texts produced using different, let's say, modalities. So it was pencil on paper or pen on paper, it was word processing, and it was WYSIWYG. And the results that came out of that research said that pencil produced high quality but a smaller amount of text. Word processing produced much more text but of a lower quality, and WYSIWYG produced more text and of a higher quality. So it seems to me that it's not enough just to say, well, what's important is to observe the fact that the modality that you write in can affect the quality and the amount. When I read that research, I immediately moved my diary to a WYSIWYG processor on a computer rather than writing it by hand. You know.
Yes, of course. Pen and paper allow different revising strategies only, because you always leave a trace, and if I do this here, there's no trace that I actually did something. So there's this difference that has been explored. The point is, you can have this, of course you can have this, I'm not taking WYSIWYG away from anybody, but there is not that the printed page where WYSIWYG came from, the printed page is no longer the target, the main target document format. There might be the printable page, but most of the text is suited to, I don't know how many pages I have, I don't know about the size, I don't know where the footnotes go. So I, as a writer, I have no clear indication of what's happening. We wrote at my institute or department, we wrote a textbook. We got a fairly structured document as style, in Word, and everything had to fit on this page with these margins and this highlight, etc. So every section should go into exactly one page. And of course, when the book was printed, this design hadn't been used. So the page breaks were at a very different size, and this put a lot of pressure on us authors. Maybe we would have been freed getting the actual layout, but I'm not sure about this. Having a different requirement like length of text, that's something else than having a length of text or number of sentences, number of words compared to please make sure that it exactly fits into this one page, because in the end this page layout might change and I'm not able to control anything about this. Visivik has an effect, but it only holds if the actual final, the only final output is the page I'm targeting, and that's not necessary. That's not vanishing, but that's losing ground.
Okay, there is another question or comment from Mike A.
Hello, when I'm writing, I feel there's a discontinuity between writing one-dimensional text, where you can just keep typing and it doesn't matter too much what happens and you can leave the system to sort it out. And as soon as you get into 2 dimensions, when you start having tables, it becomes much more important what technology you're using, and there's then a relationship of the tools you're using to the visible layout of what you're producing that's quite different. Have you any comment on editing tables?
Table, what I'm presenting here, table is in this sense a non-textual element. So this has been this is structured, of course, and I want to show this in a specific size and layout. This name goes plots, and I want to make sure that this appears exactly as I designed it. And there of course is a mixture then. And then it depends on if in the final document, if this table then has to be maybe rotated to fit on the final size, or if it is very small and I have to zoom in if I'm living in the digital representation, or if I say, okay, this cannot be printed, so please, dear author, produce something printable. But from the very beginning, so there is this mixture of elements.
Okay, and we have time for last question from Tobias.
Yeah, hello. Your talk seems to start on the assumption that when you're writing a text, you really have to write it once, on the idea of cross-media or single-source publishing, and the text will stay the same for every channel. But we see more and more that you really have to rewrite the text for social media, restructuring the text for web publishing and all that. How does this go together with your talk?
First, you also have this with dynamic documents or living documents. I'm also referring to the observation that the text will change because there are new developments. You have this text that you consume at that moment that you look at it, and it might have changed. It might have been extended. It might have been reduced. It might have something has been skipped or commented. So this also goes for me under the term dynamic or living documents, and because your text is changing. These applications, and you also see the GitHub used for non-programming tasks. So people do just ordinary, they do their websites with GitHub, they do their websites with wiki software, and you can change it easily, your document adapts. You just change content. So this is, I think this fits with this observation. And we somehow, in this respect, we somehow see maybe a similar use of tools not intended to produce documents or not intended to produce ordinary personal websites. When we look at things like wiki or wiki-style things or GitHub representation, which have been produced to, or originally were thought to support programmers, but not people showing their vacation photo gallery or something like this. So it's today it's very easy to use it for something else.
Okay, thank you very much. So thank you again. And you have very nice T-shirt, by the way. Okay, so thank you very much again, and we will disconnect you. Sorry about that. Bye-bye. Okay, so this was last session, but we are not finished today. There will be a social dinner, and part of this dinner will be Demo Jam. Is there anything about Demo Jam which Mohammed would like to repeat?
Yes, so there is few slots left, so if there is still people that want to engage for Demo Jam, I just recall the rules. Demo Jam is you come with your name and an idea, a presentation. It should involve a screen, but maybe we can relax the rules, I don't know. And it's supposed to be, I think it's 600 seconds, so it's 5 minutes in UTC time. Sorry, but 300. Yeah. Don't listen to me. I say bullshit all the time. So everybody knows that. So that's the, and it happens at some moment during the night. So you have to be sober, well, or not. We don't care. So see you later.
Yes. So the dinner will take place in the same location as in the past. Is there anyone who doesn't have been there before or doesn't have anybody who can? Okay, so just raise your hand and other people just get those people and carry them to the location or follow the crowd. Okay, and there is also on the registration desk there are papers with the map and location information, so it should be easy for you to get. It's a question or? Okay.
Where will we be tomorrow?
You mean the room? Yeah, we will be here tomorrow, starting at 9:30. Please don't come earlier than 9 o'clock. And the dinner is from 7 o'clock. Oh.
So tomorrow, just so the meetup, which meetup do we have? So just to recall.
Yeah, so tomorrow in the morning there will be Schematron's users meetup. And in afternoon after lunch there will be IXML tutorial. And then after the coffee break there will be Saxonica users meetup. Name of what? Just grab the paper on the registration desk, because I don't know. Because it's the same location as MAS, but it changed name, so I don't know the new name. Okay? Tomorrow we will be in the same room as today, this room. But you can change the chair if you wish. Okay, any more questions? So see you in less than 2 hours.